All right. Hey everyone, welcome to my stream today. It's been a little while. Been a little while for the coconut water too. Thank you everyone for joining. Come say hi in the chat as you join in. I'm excited to be back. I've been, as I kind of told everyone earlier in the year, been doing a lot of research, a lot of exploration, and I feel like my last few streams, especially the end parts, have been pretty much only relevant to framework authors. I'm not going to say that's going to change necessarily today either, but I've had a lot more time to work on these things and flesh out the ideas. Really interesting stuff, well, at least stuff that excites me more than a lot of the problems I've been working on for a while. But that's not the interesting part of the stream today. The interesting part of the stream today is that we're gonna have Dev join us, and that should be a lot of fun because he's been playing in an area that we've covered a couple times on stream. I've done some like general topic stuff, but not an area where I have any sort of expertise, so to speak, right? Thanks for coming in and saying hi. Hello. Only relevant to cool people. Yeah, that's how I roll. But yeah, no, we're gonna be talking about server signals, I guess, or this whole topic of having full stack reactivity, which I have to admit is not a topic that I have much experience with. Reactivity is mostly synchronous, right? It's all about synchronization. Synchronizing something that is async is like it's like fundamentally a different zone or a different problem. I've left that to the RxJSs of the world and to other solutions, but there is obviously some nice benefits to having kind of like a single mental model, I think. I mean, honestly, I haven't kept up with this too much. So Dev will have to tell us himself. Coming off his solid hack win, actually, the solid hack we ran actually recently finished, which was pretty cool. Honestly, I'm so excited whenever we can make it happen. It's the second one we've done. You get a big prize pool, great sponsors like Netlify and Sentry, and essentially we're able to facilitate a huge amount of growth to the ecosystem this way. Even though, not everyone can win, the benefit that comes from the projects and the people getting involved and getting in the community is immense. I can't really put a value on that. It's incredible. Anyway, we got 115 people here already, so maybe it's time to start rolling. Maybe a second. I still use the Twitter app occasionally and Blue Sky. And we should probably tell people that we're live. Although I guess Twitter knows we're live because it literally has the live stream on Twitter. So maybe Blue Sky is the only place where I have to do it. More people coming in and saying hi. Hey. Yeah, don't forget to like and subscribe. And let me also get Twitch going here so I can see you all in the Twitch chat in case people like to subscribe and give you a shout out. Let me see here. Yeah, there we go. Some of you are already coming in from Twitch. All right. Just doing my normal beginning of stream bookkeeping here. Let's see if I can even share my screen. It's been so long. I wonder if it even works. Oh, good. It still works. All right. Live. All right. Perfect. That's an interesting preview for my Twitch channel. This is a picture of me at like 32 years old. It's like not quite 10 years ago. Anyway, I don't know. Do I still look the same? All right. Let's get this going. Ring the bell. Yeah. You like that? Yeah. All right. Yeah, I wish I could just put this thumbnail again. Anyway. Let's get back to this. Let's actually let's see here. Oh man, I used to be so much better with StreamYard, but now it's like it's all good. Let's just let's get Devin here. I think it's time. Let's invite him on. So without any further ado, welcome Dev to my stream. How you doing?
How's it going? I'm doing great. Thank you very much for having me on here. It's a real kind of feels like I made it. This is a stream that I used to spend so much time watching, and now I'm on here.
This is a long time coming. Honestly, you've been a member around our community. You've been doing great work for several years now. Honestly, people might not have realized Dev was a big part of that Strello demo we did a few months ago. Plus all the WebSocket work, the stream work. You recently did the stream library. You're gonna have to explain all this stuff to us at some point, but
Definitely.
yeah. Oh, I mean, I can answer this one quick. With service signals, we attempt to do resumability like Qwik into signals. Actually, maybe I'll let you try and answer that first. What do you?
I mean, it could be. To be honest, I did not think of that angle until you came up with your server signals as an architecture document. But
Yeah,
until then, I did not think that something like this is like possible or something that could be done, like explored in the future. But maybe.
Yeah. I for what he's talking about is I did a HackMD a while ago. It isn't the primary goal here by any means. What sorry, what I'm like signing into GitHub in the background. What Qwik does is fundamentally different. It is interesting though, it's more the other way around. If you could apply a Qwik-like compiler to server signals, you could do crazy stuff that goes beyond what Qwik does today. Qwik's still kind of like what our mental model is for a single page app. The server is not stateful. If you combine Qwik's kind of compilation with a stateful server, it's like an I don't know what to call it. It's like a new live view. It's like granular live view. Yeah, sorry. It took me a while to find the exact thing you were talking about. Right? So this just posted because I talked about this on stream already a while ago. It was this idea of like taking something that's like live view and then looking at basically resumable compilation. I've done this work before when I was working on the Marco team. We were doing compilation very similar to Qwik with the resumability, because basically they work on the same sort of problem. And I realized that same kind of compilation might be really cool with server signals, but I don't think that's where we are yet today. But if you want to get really deep into it, watch, I think it's a few streams back. When did I publish it? This can kind of tell you 2 months ago. So a stream 2 months ago, I was talking about this. And yeah, anyway. Sorry, let's get back around here to you. Yeah, I know that went straight off the deep end. We'll answer more of those questions a little bit further down. And yes, we will be talking about SolidSocket and a few other things. But I want solid events. That's the other library you got? We'll talk about it. But I want to first hear about Dev himself, because I think you guys, he hasn't been on the stream yet. And for you all who don't know him, we should all get to know him a little better. So how about you tell us how you got into like development or front-end programming in general?
Yeah, honestly, it was a couple of my classmates who got there before me, who like kind of found their way around Adobe Dreamweaver, built some nice websites, won a web design contest, and then they were showing off like what they built to our class. And I saw it, I got immediately hooked. Like I want to be able to build stuff like that, like build those kind of cool animations and interfaces, websites. That's kind of where it all started. That was like high school.
Yeah, I was gonna say
And yeah,
when was that for you? Just not to give away your age
yeah,
or anything, but like I use Dreamweaver too. But when I used Dreamweaver, I
yeah.
think it was probably a lot earlier. I suspect.
Mhm.
Like I was into Dreamweaver like in 2002, 2003.
Yeah, this was 2015, 2016. So like way after its age, but because like I was back in India and in kind of in a city where like tech doesn't really like basically tech lags behind a lot, like a few years, half a decade or something like that, where I come from. So yeah, Dreamweaver was still kind of cool in 2013, 2014. And some of our books were talking about stuff like Dreamweaver. Like our web dev, our information technology book taught us how to build with ASP and VB script. So that's what we were learning
Yeah,
in school.
yeah,
So yeah,
exactly.
it was, everything was
That,
lagging behind a lot.
yeah, that, I mean that is 2002, 2003. That was VB script time, and yeah, that's that's fun.
Yeah, and around 2014 they changed the curriculum to PHP and JavaScript. So that
Right.
should
That's fast
yeah.
forwarded it up to like 2005. Yeah.
Yeah, a decade after that.
So yeah, no, I mean, very very humble beginnings, let's say. So, but like, where did you go? Where did you go from there?
Yeah, so when I graduated high school, I had kind of a gap of like 1 year before I started college, and yeah, all traumatic memories. So in that whole year, I kind of dedicated to like, okay, I have to prepare for SATs, but that's not going to take too much time. I'm just going to spend the rest of my time trying to like flesh out my web design, web development skills. I did a bit of jQuery that made sense. I tried to make sense of why JavaScript frameworks exist. I couldn't for a long time. I tried to make sense of like Node, NPM, and the entire ecosystem. Again, it took me a few solid months to like get over that entire the tutorial hell. Eventually I found Backbone.js. So again, I'm still like, this is still like 2016, 2017. I'm still lagging behind quite a bit.
Right.
But I
So,
I find Backbone.js. Yeah.
I
And
mean,
eventually
Backbone
I find Meteor.
was
That was kind
okay.
of, yeah.
Okay, so that's the path forward. Because yeah, I was gonna say Backbone was pretty sweet.
Mhm.
Again, I have a lot of experience with
Yeah.
Backbone. The startup I did was based on Backbone, and I built one of my early projects was working on my first AST compiler project was compiling back and forth between JSON and SQL queries and Mongo queries for an ORM built onto a full stack ORM built on Backbone models. So it's called Backbone or ORM,
Wow.
but yeah, okay. Yeah, so Meteor I never got into because it was in
Mhm.
that weird little time period when like Meteor originally was really popular. I want to say
Yeah.
between 2012 and 2015-ish. Like it was in that
Something like
gap.
that. Yeah.
So what was Meteor for those of us who aren't as familiar with it?
Yeah. So you can think of Meteor as like probably the first full stack JavaScript framework. I like to think of Meteor as like the full stack experience that we are chasing yet to this day.
Okay.
Because Meteor was legitimately like some of the best experience that I've had building, like going from 0 to 10 to 100 very quickly, full stack, all in JavaScript, without a bunch of like glue logic that we have to do with HTTP, with network, with state management, things like that. Yeah, Meteor has been, I'm pretty sure it has been a big influence in a lot of frameworks. It has definitely been a big influence in my entire kind of journey and how I look at frameworks and dev tools right now. So, and going more in technical terms, so Meteor was, first of all, it locked you into MongoDB. So it said that, okay, we're going to use MongoDB. We have like our own little ORM on top of it. That's how you're going to build your backend. Then it had something that we now know as a sync engine, which is basically it streams real-time updates from the database to a client-side like a in-memory version of MongoDB where all the data is stored in client side. And from there, it had reactive updates. So it had a system called Tracker, which again we now know as Signals. Angular Meteor. So Meteor was primarily a full stack framework. Then it as we started getting React and Angular, it took more of a front end agnostic role, in the sense that, okay, we're just going to expose all the data and you use it however you want. But it did have a templating engine of its own, which later kind of branched off as an independent project called Blaze.
Okay.
So that was kind of the stack of Meteor. Yeah. Go ahead.
Right. So the key part of it was, at least my understanding is, it had signals, it had reactivity primitives, and then you could basically wire the stuff all the way across. So you could basically go, here's a signal that I could update in the client that goes all the way through to the database. It was piped almost all the way through.
So not necessarily. The signals, the reactivity still was completely client side, in how Solid or any other framework does it. The full stack part was completely hidden from us. It was a system called, it was basically like PubSub. So you would define MongoDB collections that you want to expose to the client. And on the client, you just call subscribe to them, and they were automatically subscribed to. And you had a whole client-side in-memory store, which had the same querying syntax as MongoDB. So the same queries that would go to MongoDB, you could use to query your client-side store.
So it was offline first,
then,
10 years ago. It's these sync engines.
In a sense,
thing.
Yes. Yeah.
Because everything was semi-persistent connection. And if something updated, you could get live query updates coming from to all the clients, right? It had that WebSocket type of thing. Sounds like
exactly,
local
yeah.
person. So this is
over WebSocket. It sent okay, here's a collection, add something to it, remove something from it, and then on the client side, it would expose these queries as signals that you would then consume in your templates.
Yeah, a bit before its time. Yeah, we're talking. I mean, this is the thing you gotta. I don't think people understand enough, and I hammer on over and over again. Before 2009, there wasn't really much going on in client-side JavaScript. There's jQuery. People were kind of moot tools, a bunch of these tools that let you manipulate the DOM and be able to get the UI going, and you'd add some JavaScript. But at a certain point, this just started accelerating, right? And we started getting frameworks and people trying to build all their client-side logic in the client. And between, I would say, 2010 and 2014, basically React is what kind of ended this time period, for better or not. I don't know if that's their intention. There was so many different approaches people were trying to take to this problem. From heavily reactive stuff, things like Knockout, to Marco came out during that thing. And they had, islands and partial hydration. We had Meteor, which was doing this kind of almost, as you said, almost like a sync engine kind of thing. What other technologies from that time period? Out of order streaming, another one of those Marco things. And there was template engines that came almost like Pug, things that came right in Node that did out of order streaming. So all these technologies trying to bridge the client server gap, and then React won and everything else disappeared. So now 10 years later, people are trying stuff again. It's interesting.
And you want to talk about before its time, RPC actions, they were in Meteor. Meteor had RPCs. Meteor was one of the first frameworks to adopt GraphQL, and they believed in GraphQL so much that they completely abandoned the team abandoned Meteor and started building Apollo. So Apollo team is what Meteor team was. They just completely dissed Meteor because they believed in GraphQL and obviously React.
Yeah. I mean, because the React's handling of the client side was so good comparatively that, it is interesting though, because I mean, part of it is on the software side, on the programming, React, mental model, all that side. The other part of it is the changes of infrastructure that happened at that time and the changes in how we deploy, because coming out of 2007, 2008ish, I want to say, into up to about 2013, 14, what you had was a lot of people going on like AWS, getting a bunch of micro EC2 machines and basically setting up like these microservices with like auto scaling groups and stuff like that, where you start just getting all these little machines and you're just building out all these services. People were breaking down their monoliths, but they were still managing all this stuff. Kubernetes started coming out in that time period. But the flip that happened in 2014-ish was that serverless became a thing. And that's companies like Vercel and Netlify got started almost immediately at that time period. And I feel like it was both React and that which changed the whole narrative, because suddenly, sure, when we were breaking down the monoliths and going to little micro things, they were throwaway, right? But to not even have the machine abstraction anymore, it just kind of got completely away from us. And I think the combination of both of those factors is what shut down almost everything that didn't fit the mold, at least on the JavaScript side. Because I guess the third aspect is JavaScript was accelerating so quickly that we had gone to a point where with JavaScript heavy applications, you could do things that you couldn't do in a different language, right? The combination of the back and the front end, because you can't get those back end languages on the client, meant that you have this weird storm where the infrastructure has a reason to push this way. There's a mental model that seems attractive because we need to basically have this capability with JavaScript we couldn't have before, and suddenly everything else is going to get squashed. I don't know. That was, yeah.
Yeah, infrastructure impacted Meteor in other ways as well, where like the first thing is obviously Meteor coupled to MongoDB, which at the time was probably a good choice because MongoDB was getting very popular. But then there was kind of a heavy backlash against MongoDB because the people who completely did SQL suddenly realized that, oh, we want all the guarantees that SQL gives us. So they started moving back towards SQL databases. And the other thing was the coupling to WebSockets. Meteor very much relied on a stateful connection. So as Lambdas and stateless solutions are getting more popular, Meteor is seeing less adoption there. So it kind of got shoehorned itself as a prototyping tool, or like a very early stage. You cannot really build something to scale with Meteor.
Interesting. Yeah. No, I mean, didn't come here to talk all about Meteor, obviously, but Meteor has an interesting place in the history of stuff, and now even the history on the reactivity and signals side. Because again, it wasn't a framework that I paid any attention to, but like I know like Evan from Vue paid more attention to Meteor. So when you hear him talking about the history of signals and his perspective on how this evolved, Meteor plays a big part of it. Where for me, it was like a footnote. But
yeah, Evan also worked on the Meteor team, if I remember.
Yeah. I believe so. So, but for you, it wasn't just the reactivity; it was this full stack thing. And
so Meteor was the first time I had built a full stack application. And after Meteor, like I started looking into, okay, how are like actually people doing this? And then there were like mean stack, merge stack, where the API, like you're building a backend API and you're consuming it in your front end. And that seemed like very weird to me. It's like, okay, is this how people are like, you're writing API endpoints, you're doing all the ceremony, and then you're doing extra ceremony, building these services or these like abstractions on top of your API layer just so that you can consume them in your front end. And that just seemed like a bunch of extra overhead. But that just seemed to be the industry standard for a very long time.
I see. Yeah. No, that's true, right? It wasn't until it's kind of a funny thing, right? Because it's that same kind of push time. Like the funny thing that serverless has done again, only recently is a return to monoliths, conceptually, right? Whereas for a while there, when you built an app, you were like, I'm going to build the client app and it's going to talk to 10 different API sources all directly from the client. And because of, whatever scaling with single page apps, all that kind of stuff, we're kind of done full circle again. And this is why you feel like everyone's trying to chase Meteor these days.
Yeah. I mean, in the sense that it was a good idea to try to keep the like single page app, keep the client side app completely separate. But back then, like people were also splitting teams that way. Like, okay, here's the front end team, you only write the client side code. Here's the back end team, you write all the server side code. So then maybe it made a bit more sense. But then JavaScript on the server, serverless, yeah, because all of this, like front end people or people who know JavaScript, now we want to write backend code as well because we can. And like backend in JS, it's pretty fast. It's feasible. We have a pretty good ecosystem. So yeah, and then the companies, businesses, they started combining the teams. They're like, okay, instead of front end team, you're a full stack team, and like we are also doing our backends in JavaScript. We are not going to use a separate language. It's easier, it's cheaper to have a single team that does everything. And that kind of helped this push as well, where because now the companies want a single team to be building front end and back end together. We want tools that help us build both together instead of separately.
Yep, that makes sense. Yeah, it is an interesting shift to have watched that whole cycle happen like multiple times now. But okay, so sorry, always the best questions.
I've held that title. I've held that title a couple times.
Webmaster, yeah. Oh man.
Yeah, as part of student organizations trying to maintain their websites.
But okay, let's look at. Okay, so you're into Meteor and stuff. So this is like 2018 Meteor time period for you. So where did you go from there? Where did you go from there?
Yeah, after that, I looked at React. I looked at Vue. I stuck to Angular a bit. Like, so the first framework I actually had tried out was Angular, the new Angular when it first came out. It's Angular 2
plus,
and then 4 because they skipped 3. So 2 and 4 is what I was building around with. I probably still have a to-do app on my GitHub somewhere, which I built at that time with Angular. It also introduced me to TypeScript. It introduced me to concepts like dependency injection. So also like having the experience of TypeScript that early was pretty helpful. I never had that curve of, okay, I like JavaScript, I want to keep it. I don't like this extra ceremony, because I wrote a little bit of TypeScript and I immediately saw the benefits. It was very helpful, like very early in the career. Then over time, like I also saw Nest, which is kind of like a backend framework that's very much inspired by Angular and .NET, Spring MVC, things like that. So I was very much in the like, okay, here's a full-blown framework that does everything. This is how we build things. And then around in 2020, I got a new job, and the first thing that the first project that I was put on is migrating a huge Angular 1 code base to React.
Okay,
so
that sounds like fun.
That was where I spent a few months. Yeah, that was a lot. Fun is a great word to describe it. I tried to argue that, hey, let's migrate it to Angular 2 instead of React, because at the very least, going from Angular 1 to Angular 2, there's a lot of concepts that carry over. So it's mostly like a change of syntax, a change in like slightly how we set up things, but it doesn't change how we think about like how we organize our concepts. But moving it to React was a much bigger deal. But I did get a decent bit of experience, and from that point on, all my like real projects were using React.
Nice. Yeah, that's interesting, from Meteor to Angular to React.
Yeah.
So, but you're post 2018 React, so you came in like hooks were already there, right? You were like post class component type.
Hooks were already there. Yeah, we use class components quite a bit because I was still, so this job was still like in a university like setting, which means again everything is still lagging behind. It's not lagging behind as bad as like back in my hometown, but it's university area, things still lag behind quite a bit. So we started with class components. Eventually, like midway through the migration, we discovered hooks and we started using hooks a lot more. And that's when like I used hooks for maybe 1 or 2 weeks, and I'm like, okay, there's something really powerful here about how you compose logic with these hooks.
Yeah, no, that
Right,
makes
right.
sense. It's always interesting to me when people come from different frameworks and saw hooks for the first time, what their impression was, because like
Mhm.
it was funny because my reaction to hooks are probably different than pretty much everyone else's. So it is. I love always hearing that kind of origin story. Okay, so let's fast forward. Your React dev. How
Yeah.
did you and that was, let's say, 2019 ish or something, 2018, 2019 ish.
This
How
is 2020,
okay,
2020, I started working on the migration, and
right.
then up until 2022, I was working on like the same job, but a couple of different projects, but they were all React and Express.js. So Express on the back end.
Yeah, okay, so how in two
Mhm.
years do you go from being this React dev pro Angular migrator to building WebSocket and event-based systems in Solid? What was that? I think that maybe that's a more interesting
Yeah,
journey to some of the audience. How did
definitely.
that happen in 2 years?
Definitely. Yeah. Late 2022 and early 2023 is when like, obviously, server components happen. I was looking at server components. I was looking at Solid Start. That's around the same time that I picked up Solid Start as well. Uh, I don't exactly remember what got me interested in SolidJS. Um, but I was
Theo?
definitely around your streams, like late. Yeah, Theo, probably Theo, and then eventually your stream. So in 2022, that's when I started like learning more about the kind of modern framework ecosystem, as I call it, because up until that point, it was literally create React app. It wasn't even like Next.js or Remix. I looked at
Right.
Remix and like, okay, this looks interesting, but I never got into it. Um, but then I started looking at these meta frameworks, and they were like, okay, these are solving the problems that I've always kept running into. So from TRPC to remix data patterns to then server components, I made a video about like why I think server components are exciting. Um, but at the same time, I had spent a decent amount, because I'd spent a lot of time with Meteor. I had spent a decent amount of time with Socket.io, and like trying to build some real-time stuff with that. I always felt like there's something more that can be done in this real-time space. I just haven't spent enough of my own time to look into it, but I'm also not seeing anyone else do something with this. Then in 2023, I saw your stream with Donnie about LiveViewJS,
Right. Yeah.
which
Yeah.
was LiveView's port into JavaScript. That's where a lot of this originates from, because I saw LiveViewJS, and that's when I like actually fully understood what LiveView does. And then I noticed that, okay, LiveViewJS is very powerful. It has a lot of those capabilities that I want, but its DX is like two steps behind. Like, we have already gone past like 2 steps in the DX, or we have evolved like twice, two different iterations. LiveView is behind in that terms, but it's ahead in like some other in capabilities. Like, for example,
Yeah.
this
Yeah.
rendering over WebSockets, right?
And
Because LiveView is very much class components.
yeah, and more so, LiveView has. Sorry, here's a link to the original stream that I did with Donnie. LiveView
Mhm,
has this consolidated model that actually was kind of a
mhm,
lot simpler to follow. You just like update the state on the server, and everything updates. There's none of this like
mhm.
crazy like the developer doesn't really have to worry about the communication as much, right? It was crazy.
Exactly. Yeah. Yeah, and in that sense, it's pretty nice. But again, if you're just building a React app, if you don't have to worry about the server at all, you get the same experience, right?
That
So
is true.
it's
Yes.
um, yeah, and then obviously with LiveView, all the state lives on the server, so you don't really have instant interactions. Everything goes to the server. Everything has this extra bit of network latency. So there's limitations in those sense, uh, but just this capability of like having the exact same DX that you have on the client side, but also having like the same DX for the server state is what actually hooked me in. Uh, and then the next time I saw how these could connect was server components and server functions, where the boundary between the client and server was like almost completely eliminated, and like resorted to compiler and a little bit of a runtime shim. So those were the two things that I was trying to connect. Is first of all, how can we get the DX of LiveView or LiveViewJS, and how can we get it along with something like use server, use client, where we can just cross the boundaries whenever we want.
Okay. I mean, that's a good setup for the projects you've been working on, because you've made quite a few in the last little while. I mean, you've been involved in the discussions with the server signal stuff, but you've been actively on Twitter posting little hints and stuff, being like, "What would you think about signals on the server? What would you do about that?" So, how long have you been working on this signals-based approach? Because I remember when we first started talking, you were still very much like on the React server component side of the spectrum. But a lot more your recent work that I've seen has been on the signal side. How long have you been working on the signal solutions for?
I think it's probably been about like 4 months since we first started talking. So that's around the time I started working on this.
Okay.
I wanted a more, or I was thinking of like React-centric models as well, but the first thing is that React doesn't really have a concept of global state. Like all the state is within within components, and I wanted something where I could like have some global state and I could easily connect like two different clients together.
Right. So you, in React world, you essentially have to build your own state management solution in order to like accomplish the same sort of thing. I think that's a common trend, actually, having talked to a lot of library creators. He talked to like even Tanner. He's like, I'm building, you're building a router, but no, you're actually making external state management. Like everything's external state management. It's like building some random library. It's like, no, it's external state management. Okay.
I mean, so, they figured it out, and they like put it into its own package now, right? TodoMVC, which is their own version of signals to work with with the router, with forms, with everything else.
Exactly. So it makes a lot of sense. We actually had talked about using Solid as a base, but the 2.0 reactivity was about 2 years too late. Like I'm still working on it.
Yeah.
But okay. I think we're probably in a good time where we can start demoing some stuff, show off some projects. You have a few of them, right? Or a couple of them. What do you, because you did SolidEvent, you did SolidSocket. Where do you want to start?
That's it. We can start at SolidSockets, and that's what all the setup has been for.
Okay. Yeah, because I know there are people who are curious about SolidEvent, at least an overview of how that fits into the puzzle as well. But yeah, let's look at SolidSocket here. I can add this to the stage.
Right, so we have a counter.
All right.
So classic counter. Never hurt to build a counter.
Use counter. That's like the first thing I see. I see use counter. Why are we using it?
So this is a like what some people recognize as a custom hook. So inside this use counter, we create a signal. We have our functions. So there's a very specific reason why I did this. I'm gonna like it's going to make a lot more sense in a bit. But increment, decrement, nothing special there.
Okay.
But so even if I take this counter out, or like take the signal out here in the global scope, and I'm actually going to just create a new counter so that we can demonstrate that we have global state. I probably don't need to do it for this stream. I needed to do this for like people who don't really get SolidJS. But okay, global state, right. That's what I wanted to show first.
Right, okay.
So the basic idea of SolidSocket is that you can take any file, you can annotate it with useSocket, and now this file runs on the server. And anything that we export here, anything that or like we import on the client and try to talk to, it's going to happen over WebSockets. The exact mechanics of like what is going over WebSockets, how are we talking to it, how is the state being carried over, we'll get to it. We'll get to that soon, and all of that is like basically implementation details. But that's the idea of useSocket, at least, right?
Interesting.
So right now, this doesn't work at all. Like everything is broken.
Yes.
Because one additional thing that we need to do is we need to wrap the signal that we are returning from here in this create socket memo. The naming is subject to change,
Okay.
but all we need to do is whatever signals are being returned from here, they need to be wrapped with this
Okay.
this wrapper.
It's a derived value though. That's what you call it a
Now,
memo. You call it a memo because it's derived,
yeah,
right? Because essentially it could be count, but it
that's
could
the
also be
idea.
count. It can be count times 2 if you wanted
Yeah.
it to. It's basically a function. Okay.
Mhm.
So
Yeah.
and now, sorry, you were basically.
So now we
it
have
just,
this working back.
okay. So
But
just so
if we now here's the trick. If I open it in a new tab, so this is the key here.
right. States
So this
being
works
persistent.
across WebSockets. Yeah, state is on the server. Both clients are receiving updates of when count changes, and both clients are like updating the same state because this is global state on the server.
There is a question here. Don't increment decrement need to be wrapped since they also call the signal?
These are not signals. These are just regular functions. These are
Right.
setters don't need to be wrapped. Setters are actions. You can think of them as actions. Only signals. So when you're reading from a reactive value, that's it.
I see. So the idea here, just so I'm following here, I will get a little mechanical so I can understand it better.
Sure.
Is you're exporting a function that nothing inside this function gets called on the client, and closures. None of this comes. Basically, nothing here comes on the client. So this is basically a server function that has a special serialization format for the return values, and including the ability to pass back a callable function, so the client can go, oh, hey, this is a function that I can call, and the ability to have a signal that you can read. So it's like that's the mechanics. And I guess conceptually you could pass back a normal like number like 5 as well if you really want to. It just won't do anything because it's a it's it basically adds function serialization, and it adds signal serialization over use server, and it also uses a WebSocket to do all of this communication. It's like because just trying to get my head, because this is one of the questions. Like at one point someone said, can you use server with WebSockets? And I was like, sure, it's just the underlying protocol. Like we don't actually care if we use fetch or if we use a WebSocket to do the communication. What this does more than that, in that it adds serialization for signals and serialization for functions, which is interesting because you could.
I think it's more important to look at as like serialization for functions that exist within closure scope. So you can see that I've defined this inside this function. It's closed over. You don't get that with stateless.
Yeah, which is a very, very interesting thing. Basically, if one was to enhance use server to have this capability, it wouldn't really be useful unless you decided to make the protocol basically like WebSockets or something where you could persist the server connection. Otherwise, it doesn't actually make a lot of sense. Interesting.
So another way I can do this is I can just create some a let here, which I'm going to increment in this as well. So and let's just do console log. Yeah, that.
Yeah.
So we're going to see, so this let value is, again, it's inside this closure scope of this function, but it can still, like we can still increment it. It's held in state on the server.
It's so interesting. Because the use socket code, the key to this is the use socket code is only run once per use socket or use counter call, right? Like this instance exists per use counter call. Like it's not.
Yes.
Yeah. Okay.
So,
Yeah.
which is why you saw that in here, when I started clicking on this increment, it started from 1 again. So both of these come from the same client, but because this client called the use counter twice,
Yes.
this another count was instantiated twice. So another way I can show this is just move this signal down here, and now both of these get independent state. Now this is not really valuable because this signal, like there's really no purpose to this. It's just created specifically for this client for this call.
Yeah.
So really the purpose of signals on the server is so that they can be shared across different clients.
Yeah. Exactly. Because that's so interesting. I actually wouldn't even know how you did this to have the signal itself be unique across two different like. Oh, I guess in this case they're sharing. It's the same server, so they're sharing memory, the two different tabs. Okay.
Yeah, if you have two different servers, then you'll get two different signals because this is just a regular signal.
Right.
There's ways around that I'll get to later. But yes, for a single instance of a server, you'll have one signal because it's module scope.
Oh, you're wondering about scaling issues? Yeah, I mean, this is basically the whole argument against like LiveView.
Yeah.
Like these persistent server architectures, like LiveView, Phoenix. I mean, to be fair, what is it called? Erlang. Like the underlying setup for them is made for portability and for like trying to scale these kind of systems. Like I remember the Jose from LiveView being all like, it's not just like persistent. We can move the state between machines. So if the one of the serverless instances goes down, we can just copy the I guess the Erlang VM. I don't know the right terms across, and then just pick up where you left off. Definitely WebSockets have a scaling consideration, but it's also like what this whole architecture is as a baseline. This is why I think most things don't use LiveView or use this, but it's very interesting to see this come across into the JavaScript land of things.
Yeah, and the scaling issues, there's a lot of ways to address that. Even the infrastructure that's being built that exists for Erlang, the Beam virtual machine, there are attempts to replicate something like that within JavaScript, which we don't have to get into now. But I'm trying to talk to all of these like people who are building this sort of infrastructure to kind of figure out how can like this better take advantage of whatever they're working on. So I've already talked to Sunil Pai from Cloudflare Durable Objects. I've talked to the people building EffectTS, Effect Workflow, and another one, JamSocket. So there's a bunch of these.
Right. Yeah, we got some questions and comments in the tab. Yeah, I know Sunil obviously has been doing great work with PartyKit in the past and all the stuff with Cloudflare, so he would know. It's interesting. There's an interest in this area because it changes the math again, which I think is really interesting. Green threads and Erlang Scaled are what makes LiveView work. What Dax say here? You can hand off process state, but if a node goes down, you still lose it. Okay, fair enough. The workarounds are long polling or service end events, but WebSockets are more fun.
Exactly.
Sorry here, yeah. LiveView works because Elixir's runtime can handle millions of connections on a server, and the attempts of doing this on Ruby probably can't scale. Or Node is built to be non-blocking, very async, but I don't know that it can handle like underlying. I don't know if it can handle the same kind of scale that Elixir can. Okay, we'll get some questions further up. What is this? How do you synchronize changes between server and client? That is, if you have a client and server imprinting the same signal at the same time, how do you handle that? CRDTs.
Yeah, so you don't necessarily have like a client and server incrementing. The thing is, the signal only has like one authoritative instance. Like if it's created on the server, you can only increment it by going to the server. And once you go to the server, everything is synchronous. So you can't really have conflicts because it's strongly consistent. You call the setter, it atomically updates the value, and you send like you propagate those updates to the client. You cannot update it just on the client and have it like sync back to the server on here. There's a different mechanism to do that. Again, like something that's built on top of that. We can get into it later, but you can only update a server signal by going to the server.
But have you tried to hook this into durable objects yet?
Not yet. That's going to be a fun exercise, because right now in this model, signals only exist in the global scope, and durable objects is very much where signals exist. Like state lives in like these objects, these rooms that can be identified by keys. That's not yet a concept here, or
Okay.
like trying to like it very specifically requires building around that concept of state that lives in these tiny boxes that you subscribe to, or that you address by a key.
Makes sense. Okay, yeah, because it's interesting. What's really impressive about that demo, obviously, is that like it took so little like effort on the developer side to do the switch. There's a PR, adding WebSockets to Solid Start that I haven't merged because I'm like, I don't know what the shape of this should look like. Part of me was like, do we just increase the capability of use server? Because one of the things that is still obvious is the wrappers still kind of being necessary around the return values from the connection. So there's like still some pieces, where like if it's manual, you could hop on other mechanisms. This has my head like going off in different directions. So I mean that's a good thing. It is interesting because I'm trying to picture what to do with this. Like I think it's very there's the mechanical aspect, which is really interesting, we should talk about, and then there's also like it is mostly like a mechanism for subscriptions, right? Like it's mostly a mechanism for like you like the big benefit here is that synchronization between the different pieces more than like that's probably the biggest benefit. I don't know what's your perspective, because I've been the part that I've had the hardest time trying to figure out is like, cool, I can do this now. I guess it's just you want to pretend like your state is owned by everyone, essentially. Like this is that zone where you're like global state, like global state, like not just to the user, state that it applies to multiple users or all the users. Which is sorry, this is just me talking out loud, but I start seeing why maybe durable objects have the room concept, because it's very rare that it would be every user unless it's a very simplistic app. So yeah, I'm just trying to like think of examples of the kind of things that I would want to do with this, and it would be like, I don't know, like, yeah, it's interesting. Like it's almost like a database. Like it's almost like like the raw thing.
Let me show you one example that I have.
Sure.
Yeah. This is I do think that thinking of this in terms of like this is kind of a replacement for your database, or especially if it's something like convex, that's probably like closer to the mental model that is that works the best here. But this is the demo that I really like showing. So this is presence. So like these are two different windows that have like the same to-do list open. So if I add something here, you're going to see it added here. And like I have this shared cursor thing. So I can hover here, I can see that.
Is this just a modification of the Solid Start base to-dos app? Like it's TodoMVC.
Almost, yeah.
Does it have like the optimistic updates and stuff built in and all that kind of stuff?
I think it has. Let me check. It's been a while since I built this. Components, to-dos. Yeah, so it's using the event log. So it's very much reworked.
Okay.
Like a lot of it is not the same code at all.
Okay.
This is using like my little sync engine that I built for this, which we can get into later. But what I want to show here is how easy it was to build this presence. So like moving the mouse around, and you can always see this. This is what less than 50 lines of code. All I have is like one global signal that contains all the users that are online and what document they are looking at right now.
Right.
I have this use cookies little context helper, which gives us the cookies that obviously, like if you want to do authentication, and this actually receives a signal from the client. So if I look at how use presence is being used, this is the component, and I'm again using createSocketMemo, but this time I'm passing a signal from the client to the server instead of from the server to the client.
Okay.
And this is the mouse position. So this is using our the mouse solid primitives to get the mouse position.
On the server, I see a create effect. How are these reacting right now? Did you have to hack the reactivity back in? Because I turn off the reactivity on the server on Solid by default. How did you get that to actually work?
Yeah, that was. We talked on the Discord for that, and it requires like
import map
changing these to what is it, dist /
that's fine
solid. So there's a Babel plugin that does that, which I had to get OrjDev's help on it because I know absolutely nothing about build plugins. So all the build plugin stuff is either done by Nikhil or by OrjDev.
Right, that makes sense.
That's not me.
Yeah, so okay, that makes sense. And I mean, in the future, the signal stuff will be separately importable, so you won't have this concern. But yes, okay, I was curious how you got there. So these are effects and signals like this. I was wondering when you would need an effect essentially on the server, and you've just shown me an example of an effect on the server.
Yeah, there's everything. There's an effect, there's a cleanup, and there's a memo.
Yeah.
So this shows all three.
So what is this doing? Just so I can get it. Okay.
The effect. So the effect subscribes to the signal that comes from the client
for the mouse position.
It updates it updates our global signal using its values. So if there is an X and Y, so the mouse, we can probably remove this to make it easier. Never mind, TypeScript. We basically update the global signal to look at, okay, this is the document ID that I'm looking at. Here's my user ID, and here are my X and Y coordinates. So it updates the global signal.
Interesting.
Then on cleanup, basically it removes the user from the global signal, so you don't see their cursor anymore. And here, this removes the current user from the global signal so that we can return it to the client, and the client can show all the other users that are looking at the same document.
Interesting. Okay. Yeah. So the first thing that comes in my head is like, could this be written without a create effect? The idea of effects on the server is like a whole other.
I tried.
Right. I know. I was like thinking, like, is this a projection? Like, it's fine. It's actually tricky because you'd have to flip the direction of it, because instead of presence being a signal, presence would have to be something that is derived, and you can't derive it it would be very difficult to derive this in that way.
Exactly.
Like the sources are from you. This is an interesting problem space. We'll talk more about projections later. Maybe even keep you around for a bit of that. But it is challenging to represent certain patterns as derived values. It is possible, but there's certain principles that you have to follow on how you construct that object. And as it turned out in the Strello demo, everyone followed the rules and it worked. But I was talking to Milo and he was like, man, this primitive scares me because people can do really dumb stuff. Anyway, I'm like, any dumber than create effect?
Okay.
And any dumber than create effect? And he's like, no, but
that's fair.
Anyway, okay, so that's cool. Yeah, I mean, I think everyone understands this code. You basically have a global server signal. You pass in a signal from the client, which triggers effects to update the global signal, which then is listened to by the other browser that end up, applying that change, because there's clearly something derived from it in the client that actually renders the thing. Here you're just doing synchronization on both sides, create computed to create effect.
This is just create projection. This is my makeshift create projection in Solid 1 without 2.0.
Exactly. Yeah, exactly. So, yeah, I mean, yeah, it's like an async store kind of thing with reconcile. Yeah, no, this makes sense, and it's very cool demo. As you said, it didn't take much code, and this is a great example of like showing where people's like most other users' positions are. Sorry, I'm like zoomed right into it, then I'm like ignoring chat completely.
Oh,
That's why.
should I bring it back?
Yeah, maybe in a second here. Built again just like this on Node.js servers over WebSockets, found scaling to be very wasteful, only to horizontal scaling works with machines, makes sense. Signals are just a thin wrapper over PubSub, but mine is also never to be SSR for use case. Most of my components had 3JS. Don't drink and derive a signal.
That's true.
Oh yeah, thanks Fuzzy for reminding me. Again, like, subscribe, follow, whatever it is. Really helpful to the channel if you do that. So
Smash that like button.
Much appreciated. Yeah, I mean, we could talk about derived stuff a bit later. I want to continue on this WebSocket stuff, but it's very interesting. Like, people are talking about scale, and that has always been a consideration. But there is a definite interest in this area. I think I might have mentioned on stream, but I'll mention it again. Between the last week or second half of August to the NestJS conference, I had 5 separate companies, groups reach out to me about local first sync engines, WebSocket type technologies that I booked meetings and met with and stuff. 5 different startups in that time period wanted to talk to me about Solid and Signals with it, because obviously I think people kind of get that Signals have the potential here to do a lot more. You know, you can keep that granularity. So there's definitely an interest here. I don't know if there is some mechanical change in the future that's coming down the line on the infrastructure. Like, there's something coming that's facilitating it, but there's a lot of interest. Like, not an AI or blockchain amount of interest, but more interest than I've seen in this sort of area since like back when everyone thought they were going to be their own hosting company. So it's been a while.
Yeah, I think it's
Does AWS support WebSockets yet? I mean, on EC2 instance you set up, but on their serverless, I imagine they don't have any way to do persistent, do they?
So they can support WebSockets, but you don't have in-memory state. It's like you have stateless functions that get called when there's a WebSocket message that comes into their API gateway, their piece of infrastructure. So every time there's a message, you have to go to your database to figure out what you need to do exactly.
Just run a container, guys.
Yeah. This is deployed on Railway right now.
Okay. Yeah. So there's a question about people wanting to check out like these code examples. Can we share them? Drop the links in the chat. I can try and remember to put them in the description later. But let's yeah.
So I can't go to the chat from StreamYard, but I have it in the private chat.
Okay.
The URL to the SolidSocket repo.
Yeah, let me.
The repo right now is both the package and the demo. I couldn't figure out how to like extract this into a separate npm package that you can install in any SolidStart project right now, because again, I don't like build tools and I don't know anything about build tools. But so right now it's just like one project that you can just modify the code. But this presence demo is there. There's a to-do application that's built with a little sync engine, so it has optimistic updates and everything.
Yeah. Okay. Let me see here. So I'm gonna just pull it up right here.
Let's do it.
Move the link. Hey Dave.
What's up, Dave? Thanks for being up so late.
Well, it's
oh wait, no, it's early for you. You're in Pacific time. I forgot.
Dave's East Coast, right? So he's like 4 p.m. All right.
Wait, I thought he was West Coast. Okay.
No.
Anyways.
Yeah. Okay. So yeah, SolidSocket repo, and then we got the source code, which it's what do we got here? Is it public? Like this looks like a SolidStart repo.
It is. Yeah. The socket folder has all the like implementation for how this works, and the source
Oh,
code is
okay.
in the SRC is the demo.
Oh, I see. Yeah. So this is your actual this is your
Yeah.
actual source code. So is this packaged as a library, or does it just live inside the solid start?
It just lives inside this project right now. That's what I was saying. It's not packaged as a library right now because I tried to do it. I couldn't figure out exactly like how to get some of the things working.
Yeah, part of the tricky part is like I imagine the compiler pieces and how they get like them to play in a generic way. Yeah, but okay, so you can basically set the source folder is the demos, and then the socket is the source for the libraries, right? Because I was like, this is just a standard solid start app. So you have an index route, and you have a user ID, which is the presence stuff for the to-do app, right?
So both of them, yeah. So you can have like your own to-do list, but you can also share, like invite someone to your to-do list. So if I'm on /Ryan, then I'm looking at your to-do list instead of mine.
Yeah, no, this is very cool concept of a project, like in terms of where, yeah, I think this is an relative. People pointed to earlier, there's a scaling consideration, there's maybe even security considerations. It's a very interesting area, but it's very raw, but it has the potential of changing the math a bit. These apps, are they SSR'd? Like, do they hydrate? Like, there's a question earlier on. Okay, there's a question earlier on is like, how do you handle stuff with hydration? Like, would it be out of sync if there are changes before or during hydration? And I have to assume that the only way hydration works is if you take a snapshot at the time that you server render, hydrate it, and then basically don't start playing back the events from the WebSockets until after you're done hydrating it. It's an interesting challenge with like stuff streaming, because we would probably, the first time a new event come in, we'd have to basically cancel any future hydration. So like, I don't know. It is interesting.
Yeah, I haven't messed around with that too much, but I would assume that things can't really change during hydration, because if something changed, you need a WebSocket connection to know what changed. So I would assume like all the hydration happens before WebSocket connects, and once WebSocket connects, you receive all the updates, like anything that changed since you server rendered, and
Right.
like it because it happens after hydration, it's just updates.
Yeah, that's how I think of approaching it, essentially, because the whole loading stuff is happening via the serialized data. And even if you delay to the very, very end of hydration, like till the stream is done, it's not the worst case scenario in the world. There might be like that like jump up when like the bunch, like the new state comes in like a bit later, like it takes a second or so. But on the other hand, compared to what you had before WebSockets, like it's no different. You know what I mean? Like your page never updated. So, I mean, what are you complaining about?
Yeah, it's only an additional capability. What I would be more interested in is rendering within the use socket, which would require probably a different type of like reactive renderer that works over WebSockets. I was trying to build one last night. I couldn't, I didn't have enough time to properly think it through.
So, sorry, were you trying to like render HTML over the socket? Like, essentially, like, when you say render, do you mean like basically render pages like HTML via the WebSocket?
Render pages, but also like dynamic rendering, where like within a use socket, like I can put all the counter JSX, the button and the div and everything inside my use socket, and just import it and render it within the client. So not only does it like render into HTML, but it also updates. So if the count updates, the server knows that there's a text node that needs to be updated. It sends the client a message saying that here's a text node, update its value to 2 to 3, and the client just does it.
Yeah. Okay. I see what you're saying. Yeah. So because you're dynamically, like when you create the socket, you're dynamically creating the like wrappers around the specific signals, what's to stop like another level of dynamicism where those signals are creating things that create signals that that can update in the future with other things that can have signals in them? Yeah, I see what you're getting at.
Yeah, I see the mess is probably easier to do that with a VDOM. I'm like half agree, half disagree. So it's kind of it's a VDOM in the sense that there is a representation of the real DOM on the server, but it doesn't serve the same purpose. Like it's not something that you build huge chunks of and then diff with each other. It's something that you fine-grained update just in the holes. So first of all, you get to skip out all the static stuff. You actually only have in memory the things that update over time. And then you don't diff and patch anything. You just say that here's a node, update the text to this.
Yeah. I'm getting you. What you're saying, it's a virtual DOM, but not in the sense of like the React virtual DOM. It's just like a virtual DOM because you don't have an actual DOM in the on the server. So you to keep things in sync, you need a representation on both sides. So instead of using real DOM nodes, you use a virtual DOM. But that virtual DOM on the server is actually being fine-grained rendered. Like it's actually it's being updated the way Solid does updates.
Yeah. So it's a very interesting like concept for a virtual DOM that I don't think that it exists right now.
Yeah. Well, because there's no benefit of doing that in a client-only zone because it's just an extra layer. It's funny that there's actually a lot of similarities between that and like what I've been working on the stores side. Just like a tangent, because like this idea of like diffing, like immutable states versus patching the changes. What you actually want on the server is a virtual DOM that's actually a proxy, more or less, so that any upgrade can actually, it's like immer. You want to record the change, essentially. Like you basically want to know what the changes are, like sense them, fine-grained, and then push them along to the client and be like, it changed in these specific locations. So yeah, it's almost like a way of see, and then you start wondering if you can shortcut it. Sorry, because what I'm hearing is it's like a way of going from signal to affecting this thing, and then going back from that effect to creating a patch to basically communicate against signals to the client to then basically affect into the actual DOM. Like, which seems like it's complicated or seems like it's involved, but what you save by doing that is there's actually no diffing. It's just the bulkiness is that you couldn't make the whole thing derived in one chain. You had to actually go from derived to push it out effect to get back to something that can be derived to push out again. Anyway.
So if you scroll down to, there's a section in the README called createSocketStore or createSocketProjection. There's one of each actually, which do something very similar to what you're describing. So we have createSocket memo, but createSocketStore, you pass in a store instance, a store proxy instead of a signal, and you listen to it like fine-grained on the client side. So you only get updates for the key for the values inside the store that you actually listen. It doesn't actually work because first of all, the proxy traps were a little bit too complicated for me to figure out, and the second thing is that like you import store from SolidJS/store, which then imports SolidJS on its own, and the Babel plugin I was using to transform the imports doesn't work on node module. So there's a couple like small reasons why this doesn't work yet, but this can be implemented.
Right. And what I'm getting at is almost in a sense, if you had something like this, you could basically use a store on the server as your data structure for your like abstract virtual DOM. And then when you update the specific parts of this virtual DOM, the store could do the fine-grained updates across the wire. Yeah, no, this is kind of crazy. Question: why do we care about having a data structure on the server? It seems like only use cases for collaborative apps.
Yeah, I mean, I mostly agree. The thing is, right now, collaborative apps, like if you want to build collaborative apps, you have to buy into a lot more complicated things. So this is just a simpler thing to help build collaborative apps and
Yeah,
something similar.
I think that's like the whole point of this. Like, you don't really
Mm-hmm.
need this capability. You need this data structures on the server, and this, because you do pay costs. There's the scaling costs. There's the fact you need memory on the server. You need something persistent. But the trade-off is collaboration, collaborative apps, so you can have this like single state. I'm trying to think of. I think that's the biggest one. What other benefits do we have to using these kind of WebSocket stuff? Things up to date.
I mean, any sort of a like a real-time dashboard.
Yeah.
Like if you look at like you go to Vercel dashboard, Netlify dashboard, a Sentry dashboard, like all these are meant to be real time. You're meant to like, okay, I have this app open and I want to see in real time what is happening. So you can have signals representing those that
Right.
piece of state that you want to observe.
Single source of truth too. Sorry, Jose did this whole thing about why optimistic updates suck and all this blah blah blah, and like he's going through this whole example. And the truth of the matter is yeah, obviously optimistic updates suck because they have to approximate something that is not real. Actually, and LiveView doesn't actually change the math on that too, because it still has to start from the client if you want it to be optimistic. But generally, if you have a single source of truth, a single persistent server, a single way of doing this, you will have more consistency if what's important to you is stuff like real time, where it's not, you don't want things like, you want to shorten the eventual and eventually consistent, right? You want you want to make sure that like things aren't sitting out of date too much.
Yeah, and things like single flight mutations do a pretty good job at like making that half, or really reducing the amount of latency or the amount of time you're looking at something out of date. This kind of takes it a step further, and it also ensures that anytime something happens on the server, you always get that up to date. And the problem that Jose brought up, another problem, which was that updates can be seen by server out of order. So if you said like delete 3 things, it might delete the third thing before it deletes the second thing, and then when it sends back an update, or like when it sends the updated data, you have something that doesn't represent the real database. So again, things like that get smoothed out with WebSockets because all the messages happen in order.
Although, to be fair, I suppose a WebSocket protocol under use server would also be fine for that as well. Like that's a nature of the communication protocol rather than the. But yes, I mean these are all ways. I know he said they were smoothed out with WebSockets, but what about the Reconnect case?
Do you mean like if the client drops the connection, or like just reconnecting WebSockets, or if it's like the server shuts down and there isn't, because that's something that only Elixir can, or only Erlang can really have, which is like there's a new server deployment or the server shuts down, we can just start a new process with the same code. If it's just the client reconnection, then like we have libraries that every time a WebSocket disconnects, they'll reconnect and they will try to replay all those events.
Yeah,
it's not really sure what the question is.
It is interesting to me because Jose is kind of always like in his example, like he is picking apart something that is real, but it's also something that like if you look at all the possible errors that go wrong with server client things, you're more likely to think that it's one of those things than the actual issue. Like you're more likely to hit the other issues than the issue. Like people. Like he used an example app, which was like what was it? It was rewritten in Remix, but used like Tanstack query or something. I forget, or TRPC. I can't remember what it was exactly, but essentially, almost all the bugs you could tell weren't the types of bugs that he was talking about. You could tell by the behavior they were actually just poorly written code. Like you could actually tell that it was just like optimistic updates missing certain states, like this, kind of scenario. It was, and don't get me wrong, writing optimistic updates are difficult. It's just, it wasn't like, if it was what he was saying, what he was witnessing when he was clicking around the app would be different. And I think that we're talking about like the edge of the edge case, because basically every app in existence is almost created without taking this into consideration. That's client-based because it literally isn't something we can handle. So yeah. Oh, what did Dax reply here? He said, I don't believe using WebSockets lets you 100% avoid ordering problems from being tracked explicitly server-side.
Right. Like on the server, you might want to keep track of which ones, like which actions you've already seen. So you don't want, like you don't trigger it twice, something like that. Yeah, I don't think that's handled by default. Like this is just a simple mechanism to communicate with the server over WebSockets. If you want additional infrastructure for like, here's an update, I'll send it to you multiple times, make sure you don't do it twice. That would be like additional primitives on top of this. There's a few of them which we can get into, but Jose's position is that using WebSockets avoids this problem. Yeah, at that I'm going to delegate to you whether like he's right or not on that.
Yeah.
But to Dax, I mean.
Yeah, no, that's perfectly fair. There's a certain level of detail that I'm not aware of. Dominic actually is here, and he was saying how are errors conflicts handled if you were to mutate a signal on one client where you replaced an array and the same thing happens to another. Oh yeah. Have you thought at all about like order or like the
Yeah, I mean, I answered this earlier. Because the signal can only be updated on the server, you don't really have conflicts there. You only have conflicts when you try to like, or like using just these base primitives, you can't really have conflicts because everything is synchronous.
Right. I mean,
at least updates are.
I mean, there's theoretically that time period where, I mean, I guess you always have this problem, like where client 1 pushes the button, client 2 pushes the button, so and client 2 doesn't see the update from client 1 yet, so their expectation of what pushing the button does could be different from what they get. Like, I mean, the silliest version is when it's an increment or a counter, because in those cases, you always +1. So the client ends up, if it was at 5, first one clicks to 6, second one clicks, because they get changed in order, you'll end up with 7. But in a replace operation, like Dominic's saying, is like if they
then
saw that their own
right.
If they saw that their own state said 5, so they didn't say increment, they said set it to 6.
Yeah, or reset to 0, something like that.
Yeah, exactly. But yeah, so yeah, nothing's specific.
Yeah, in that case, there will be a conflict. You can add like some sort of a check in your mutation saying that only make this update. Like if you want to check against something like that, if you want to build your own conflict resolution, by default, it's obviously last right wins because updates just come in synchronously. And whether or not like a signal update was seen by a client before it sent an update, that's not handled by default. But because these are just base primitives, you can keep building all of that on top of this however you want. So if you want like a CRDT in place, or if you want a different mechanism, if you want a sync engine that's based on event logs, that's also possible.
Yeah, it is interesting because this does kind of open up a whole, area of consideration. It's funny because like on the base case and on the non-heavily trafficked case, these are things you almost never worry about. And then once you start trafficking a lot, and once you start doing a lot of these back and forth interactions, it suddenly becomes a thing. It was kind of like what I was saying with the Jose example earlier, where like if you're doing stuff like the way we do in SolidStart as FeltKit or Remix, and you just do your like post thing and you kind of do everything in these big broad sweeps, you're usually not going to hit too much of an issue. But if you're sitting there and like trying to update something multiple times per second, like and kind of everyone's doing that at the same time, then it becomes more of an interesting zone. I don't know. It's definitely interesting.
And that's kind of my hope that like as this gets used for like, or if this gets used for different use cases over time, those primitives will kind of like find their way as like add-ons or like little wrappers on top of this. But the API mostly should look similar to this, where you're just dealing with signal getters and setters most of the time. You're passing them around from client to server, and you have just like minimal wrappers on top of these regular signals that handle those race conditions that that you need.
Yeah, that's right. Lexical would have hit this kind of thing a bunch by being a text editor with. There are plenty of inherent issues here when it comes to complex data structures, right? He was saying that an array, but things with custom data structures are tough. Yeah. So I guess that's kind of the more interesting question is we're looking at this from a generic solution standpoint and being like, look, this is a mechanism. And then if you need to handle these like special cases that come up, figure out how to handle on top. I guess there's ultimately a question here is if like these challenges are so difficult that they almost always have to be special cased. Like I guess that's kind of the question. And if they always need to be special cased, then how generalizable is the problem space? I'm kind of, you know, we're at least what I'm hearing in this kind of conversation and thinking. I'm not sure.
Yeah,
it's distributed systems are hard.
There are like some. Yeah, there are some generalized things that we can do, and I've tried to do some of them. So if you scroll down, there is a persisted signal, a create persisted signal, which solves the problem of, So this solves the problem of like horizontal scaling, where, or it doesn't solve it. It like gives one way to solve it basically. So earlier I said that if you just have one server, you only have one signal and everyone's looking at the same state. But if you have multiple servers and you're trying to load balance between them, then the same signals are going to be replicated with different states. Everyone's going to end up looking at different things. What this does is connects a signal to basically some persisted KV database using unstorage. So you can define a key. So in this case, the key is count. And it's going to use an unstorage client to store that value in there, and it's going to use unstorage's watch method to listen to that value and update all the other servers that want this piece of state. So this makes sure that updates to a single server make their way onto all the other servers that you have scaled out to.
Okay, that's cool. The built-in thing. Yeah, I'm very interested to see how these things can end up stacking up. Dominic adds something again, probably his experience also with frameworks is interesting space where you need to fork of UI to be pending until the server says it was either merged or conflicted, and using error boundaries to handle fail case properly. Like basically, like turn these all into transactions essentially, like from or transitions or whatever from the terminology that we use in framework land. It's yeah, and I think if we are getting to a place where we are doing this like constant async kind of thing, like we always talk about like async being like, usually I think about async about being on the boundaries. So you have a synchronous system, which is the UI you describe. Then we have primitives to bring the async in, like that's what our create async is. And then you use stuff like transaction, suspense boundaries, all the error boundaries, all these kind of boundaries to kind of contain, like, I don't know how to handle this in my sync world kind of scenarios so that I can kind of massage this out. But if this is happening all the time, every moment, it starts getting really interesting how to kind of like, yeah, the transactional nature of this goes beyond. Yeah, I mean, I guess it's not untrue to say that we're just re-implementing databases in the browser, right? Like, we're like getting to a point where, like, we're getting very close to that because, a lot of the work, React Solid's initial transitional thing, we basically, there's like one kind of future, and then we try and build towards it. And if while we're building towards it, we realize that something else comes in, we kind of go like, okay, either throw it out or continue kind of trying to build to this joined future, and then you kind of get there. But there's this one target, and then when it's finally done, or when we can't wait any longer, we just go, okay, kind of update stuff to get there. But then, start going, okay, can we be more granular? Can we have multiple things going at the same time? And the easiest thing is like anything that's not related doesn't overlap on the graph. You could be like, these can do relatively independently, but when they do overlap, it's like, do you fall back to the old behavior where they all merge together, or do you try and come up with some kind of reasonable ordering system to handle the merging? It's funny because this came up on a Twitter discussion. I think I was talking to, React core team member, name's not coming to me right now, but basically he asked me this exact question and I was like, I don't know. I was planning on just kind of, if things entangled, say they're entangled and not worry about this. But I mean, we're getting to a point where maybe we can't not worry about this. Like maybe this has to be solved. And then at a certain point, you kind of start asking yourself again about the specificness of the thing is like, should we just let an abstraction like a sync engine take care of this for us? Just like, if we're trying to recreate a database on the client with signals or like a cross server single database, like maybe we should just let the database people write the database.
I mean, there's always back and forths. So this is a great kind of a discussion because the next thing that I have in the README is a sync engine. Maybe like not everyone will agree that it's a sync engine, but that's what I'm trying to that's how I'm trying to think of it is, okay, can we do some of those sync engine-y things like at a very base primitive level and leave some of the specific customization up however we can. So what the sync engine, it basically what it is it's a log of events that lives on the server. You have a method to like add a new event at the end of it, and then you can replicate it on the client. You can do the same thing. You can add an event at the end of the log, and it automatically makes sure that the same event makes its way to the server and gets appended there. So this is the server version, and this is the client version where you pass the server log into it so that it knows how to talk to it. And then on top of it, you have computed and you have projections to like build state out of that log and show it in your UI.
Yeah, exactly. Good old map reduce, basically. Okay. Yeah, and current implementation uses simple ID version approach to conflict systems. So they say, yeah, it is interesting to figure out. We're in kind of this middle zone where people are at point A and there's point B, and there's like, you can obviously go all the way to B, but there's a question like, is there a midpoint along point A to B where like there's this like kind of sweet spot, which, it's interesting. Okay.
And that's what I'm trying to get to here is that this is a sync engine, but it doesn't do like really any good conflict resolution. But what it can do is give you like ways to plug in your own logic. So it can give you a function where here's the current state of the server. Here's an update that just came from the client. What should we do? Like you can look at the current all the current state. You can decide whether this should go in or not, or you can decide whether a different update should go in. And then you can do the same thing on the client. Here's all the current state of the client. Here's the update that just came from the server. What do you want to do? So you can customize those two like pieces of logic, and then have everything else just like be built into this these like 3 or 4 primitives.
Yeah, no, this is very interesting stuff. Yeah, I mean, I'm glad we got the discussion going on this because, see, on one hand, when I look at this, I'm like, is this too narrow because of like stateful, doesn't scale all this stuff? But there is so much interest, and there is a commonality between the pieces of this technology and stuff, which is funny. Would you think would be on the complete opposite side of the spectrum, right? We're talking about offline first, where there's no server, like unless there is, like basically like you can't predict the connection being there, consistently on the back end. And there's a lot of surprisingly similar considerations, I guess, because both of them behind the scenes have to handle the synchronization problem of how do you deal with conflict resolution and the transactional nature of mutation. Okay. Yeah, I mean, it's a lot just to jump into if you're just like, can I just put usocket at the top of my file? Um, but I mean, I love that it asked the question. Um,
Mhm.
yeah, seeing here, so much discussion went in the middle. We spent so much time talking about
Yeah.
that I got like 5 minutes behind the chat, which is funny. I'm glad people have a lot of opinions on this stuff and have like looked into, some of the challenges here.
Yeah, and this is an area of like web development that I feel like a lot of the framework community and definitely the framework community has kind of like very much been hands off, like completely moved to a different focus. And like even like someone who builds Socket.io is now building like a stateless server rendering framework, and like I'm sure he back of the mind he's thinking of like how do we do real time, or how can we add real time capabilities to our platform, or how do we build real time features into our own dashboard. But none of that stuff seems to make its way to the framework.
Well, I mean, it's tricky. I mean, we're in a place now for the first time in a while where we could ask, that question, because classically, frameworks, client-side frameworks especially, they want themselves to be usable by the masses of people So the lowest common denominator classically has been like, can you render in the client, right? That's the job. We understand that this
Yeah.
is a actual category of things, and we go and get that. And then you're like, okay, I would like to also render on the server, but you notice it's also render on the server. It's not the primary function. You could say RSCs tried to flip that around
Yeah.
to being a primary function for these JavaScript frameworks, but still, would you be picking up React otherwise? I'm not sure. But now, like, it's a whole other step to say, like, okay, it's this whole step to say you need a server, and Next.js did, and most of these meta frameworks that suggest you need a server. Not completely though. Even that's a huge jump. That's why we had the CSR mode in Solid Start almost right from the beginning, and Svelte it as well. SvelteKit was client only as well. Right, pretty much had that option right from the beginning. There was an adapter for it, and then Remix added it more recently. But like, there's been this trend, because saying to people like you need a server is even a big jump. And now saying you need a persistent server is like,
Yeah.
in this world, is more. But the funny thing is, RSCs have told people that, hey, you basically can't function without having blob storage. Because without the caching mechanisms in Next, like RSCs are broken. Like it'd be like, I know React doesn't care about re-renders, but trust me.
Yeah, they don't care about that at all. They don't bring this up at all.
No, cache is so important and fundamental to Next.js, because of the way it has to re-render the pages on the server and fetch all the data and do all that stuff. You basically need blob storage or KV type storage to have a Next.js app with server components. Like, it's a baseline. So now you don't just need a server, you need blob storage, which is fine. Everyone has their own. Netlify has their own. Vercel has their own. Cloudflare. Everyone has their own kind of blob storage mechanism, but it's absolutely base stakes. It might become, we might be getting to a point where it's like, oh yeah, if you like a persistent server or something like durable objects becomes that thing where you're like, you don't need it, just like you don't need a server to use, Solid Start or
RSVs.
Svelte Kit or whatever, right? But like, it's just like, if you're getting in the full package deal, we're actually going to put a bunch of infrastructure requirements on you. Like, and if companies like Vercel are driving the ship, maybe that is where we're coming to. Sorry.
No, server waterfalls are okay.
Yeah. I think it's reasonable to say, if you want to build a very real-time app, you can't do serverless. And the number of people who are doing very real-time, I don't know, maybe it's a growing number. It's kind of funny. Like, initially, it's the evolution of the stuff. It's like really funny to me, because when we created single-page app frameworks, and I say we, but I wasn't really quite there at that point. But when people created the original single path, single page app frameworks. I was a developer at that time, but I wasn't building the stuff. There was this understanding that these are for apps. Like people would be building their .NET websites or PHP websites or Ruby on Rails websites, but they needed something more interactive. They needed apps. It'd be that just last 10%. And yet somehow that app framework, now people are like, why can't I render my static blog site with it? Like,
Yeah.
right? Everybody wanted to get what the app framework did. So we've gone all the way to React server components. Like, some people joke the PHP of React. So scaled it all the way back. If interactivity was the previous bar, is real time the next bar? Do you know what I mean? Like, is this just another example of where we're going to talk about putting tons of effort to cater to that like small 10%, and then everyone's like, why isn't my static blog site real time?
Yeah.
Like spend the next decade figuring out why that isn't.
Although I do want to question that. You cannot, like, if you want to build a very real-time app, you cannot do serverless. Do durable objects not count as serverless? Like, I'm sure you can build a very real-time app with durable objects. So
Yeah.
do you not count as serverless? What's the question there? That's my little pushback against that.
I mean, to be fair, yeah, I wonder what Dax has to say about that, but I think you almost have to always put in quote, like, except durable objects. This is a unique feature and a unique capability on Cloudflare that's very exciting potentially, but I know they've been having challenges finding adoption and stuff, and I think maybe it's because they were a very specific model. Like maybe it's because people don't quite get them, but the fact that this exists is obviously exciting because the potential's there. Okay. Durable objects require sharding, can't do concurrent reads, etc. Okay. So there are also technical aspects to it.
Fair.
See, this is not an area that I'm an expert in, so I'm glad to have people in the chat who can help out. I kind of got the last time I worked like closely with it. It's funny that like I was really working on like infrastructure side of stuff. I was really at the startup I was at. At Netlify, I worked more with the framework integration teams and like the runtime aspects, and not on the infrastructure side. So like it's been a good 7-8 years since I've 7 years, I guess, since I've really actually no, was it less than that? Yeah, whatever. It's been at least 5-6 years since I've like spent time like looking at the changes. Like back then it was like I was very happy about what was there's like something to make serverless easier. Like the serverless framework or the serverless something rather.
Oh. Serverless framework was probably it, yeah. It's pretty early on.
Durable objects are promising because they're basically the same model as Erlang, so it should have all the benefits Jose talks about, but it's too big of a step for a normal app to gain mass adoption.
Yeah, that's kind of my thought on it as well. And I guess I look at durable objects not only as like a very Cloudflare specific technology, but also like, again, as this like the actor model that Erlang has, that gives Erlang all its power, and bringing that to the JavaScript ecosystem. And this is something that's not unique to durable objects. Durable objects are doing it at like this corporate like cloud hyperscaler level, but there are other projects that are trying to do very similar things. And I think like, again, the like JavaScript is just going to have this in a few years of time, like just as like we have lambdas.
Yeah,
Effect cluster is one of them, and jam socket is the other one.
So are you're thinking there's like a primitive here to be discovered in the same way like everyone now has blob storage? Cloudflare was technically one of the first that kind of offered, well, I don't know. AWS has like lots of random services I know nothing about. They probably had a KV service before, but I remember like for me, Cloudflare very sticking out when they had their workers in the KV. It was like, here's a certain zone of type of solution. And now everyone has some version of blob. I mean, sorry, S3 is blob storage. So like, I know that like that's not the return, but you know what I mean, like the KV. Yeah, yeah, I know.
Yeah,
I said
S3
that
and
before I
SQS
saw
are
it.
the OG.
Yeah, I know. I said that before you typed it, I swear. At least before I saw it. But yeah, I'm thinking of like, yeah, it's fine. But like it's kind of been standardized to the point that like everybody has this kind of model piece. Is there going to be something around this persistent piece? And maybe durable objects just aren't quite the right abstraction yet. I don't know.
Yeah, that's kind of my hope, at least. And that's what I'm trying to build towards as well, which is why I'm trying to talk to all these people and trying to like build this, trying to build my own primitives in a way that I can take best advantage of uh, that sort of like actor model infrastructure.
Azure event. Oh, there we're having on Azure. I haven't thought much about Azure in a while. God,
Yeah,
it's
all of these are like I mentioned earlier, where they'll just call stateless functions. So
right.
you have WebSockets, but you don't have in memory state.
Yeah,
So what's the point?
which is the what the durable objects do. They give you that persistent state.
Mhm.
Yeah. God, sorry. This conversation just keeps giving me flashbacks because I worked at a startup, and depending on who was funding or supporting the project at the time, the hook for them always was like infrastructure. So it was like we started on AWS, we migrated to Azure, and we migrated back to AWS again. And I did this over a 5-year period and changed the infrastructure like each time. I went from microservice to Kubernetes to serverless. Anyway.
That sounds fun.
Yeah, especially for a guy who got into the whole web dev thing because he like making like video game like type stuff in the client. Like that's why I love like Knockout. Yeah. I people. It was so funny when I joined eBay. They're like, "You're like a technical director at a startup, director of technology. Why are you joining as like an IC at eBay?" And I'm like, I get to work on the framework. I get to work on like the like I'm done migrating from. Yeah. Anyway.
And a principal like director level engineer work is, I don't know. It sounds fun, but like most of it is just, I feel like, dealing with legacy.
Well, I mean, being a principal engineer on the IC side is perfectly fine. Like, if as long as you're not like dealing on the management side and you're a specialist in your area, and yes, you spend a bunch of time documenting stuff and writing. I love writing. What do you like? Think about me and my hack MDs. Like, that's just when you get an architecture title next to your name at a large company, you get to go and you're not managing people. That's what you get to do. You get to write a lot of hack MDs, right? So, I mean,
Yeah. Yeah, I meant more in like the leadership role, like you might have at a startup. Or
at a
like
startup, at a startup you wear many hats. So you spend, when you're in that position, I spend equal amount of time designing the technology solution, talking with the people, understanding the product needs, and also doing hiring. And it's all good.
Dave has a fun suggestion.
I wrote the original Solid doc. See how well that went. Could you picture though, like if you get those architect guys, right? I forget the name of the stupid 3-letter acronym for those documents, like the
ADR.
It's ADR, yeah. Now, like take an ADR writer and then get them to write your like generic front end framework docs.
Yeah, nope.
Anyway. Sorry, I've got off topic a bit. I don't know. Is more people want to push on the WebSocket stuff? I kind of want to know a little bit about solid events. Honestly, I don't know. Is there another demo or anything you want to talk about, get across on the WebSocket side before we take a look at solid events for a minute?
I don't think so. Yeah, I think we talked about pretty much all everything that consists of this and everything that might come in the future. The biggest two parts that I now have to get working are the socket store, or the ability to like fine grain subscribe to data on the server, and the second one is the renderer. So basically like real-time server components, so that with like the next generation virtual DOM that we came up with in the stream. Fine-grained virtual DOM.
Yeah, it's really tricky, any system where you need to synchronize the state. Like in that server architecture thing, I was talking about a similar, it wasn't, I guess it was persistent. I was talking about the same problem, essentially. Like you basically have, I wasn't talking about it as a virtual DOM though. I was talking, like, you don't have to think about it as a virtual DOM, do you? I mean, you can, it is a virtual DOM, but really it's a reactive ownership graph. It's like basically the reactive nodes, and then however you encode that this is a DOM element or this is that. I mean, it is a virtual DOM, but it could also be like a string. Like, I mean, a little bit more within arrays. Like, it is structural, but for the most part,
like it could be native views. It doesn't have to be a DOM. Like,
right.
Yeah, you could take that same thing and use it with Lightning.js for TV UIs.
Yeah. So, okay. Well, I mean, this is a lot of very interesting stuff, and I'm definitely behind the continued research here, especially because it's a good showcase of understanding. Like sometimes these kind of zones lets us understand better what kind of reactive primitives we want, because like they start putting things to the test. Like sometimes maybe I overcompensate for that. I have to admit the Strello demo was like one of those like move the marker things that I looked at. I wanted to solve that problem for so long, and it influenced things. But on the positive, I mean, we still have lots to work through, and I'll talk a bit about protections maybe a bit later. But on the positive, we seem to start finding those primitives that seem to have multiple applications and seem to fill the role properly. And it only came from finding the right, exploring different zones of these kind of expectations and whatnot. Okay, cool. So I want to look at SolidEvent then. I did that long talk, not just because I love hearing my own voice, but because I was giving people in the chat a chance to ask any more questions, but they seem good. So let's look at
There's a link in here.
Beautiful.
So I'll kind of like do a very quick segue by like talking about why I link solid events in the solid socket project. I think the two kind of can be like used together quite nicely. The main reason is signals across the network or across WebSockets are a little like more expensive than events, because with signals you have to have the current state on both sides. But because events are push based, there's nothing to pull. You just you have an event, you push it through, and you're done. So you don't hold anything in state. So events kind of like take the usocket, the usocket kind of mechanism, and can offer a more optimal experience on top of it that you cannot build with just signals. And that's all before I talk about what solid events are.
Okay. Yeah. Sorry. I know I'm changing the thing on you. I wanted to see.
I also want to see this. I wanted to see if I could actually looked at this.
I wanted to see if I could find it. I wanted to find it on npm because the README would still exist. I think if I go in here, solid rx.
I thought I had seen this. Oh, there you
go. Just before. I tried to create my own version of RxJS where I had pipe, tap, filter, map.
Beautiful.
So you go create memo, double even. Basic thing is Solid's memos are reducing. They pass the previous state in. So like you could basically like chain these like pipe through stuff like an event. So you could, I don't know if this is the same thing, but I was trying to. The problem with this, and the reason I deprecated this library, is it went almost all the way to 1.0. If anyone knows, the last version of Solid before 1.0 was 0.26. It was I made a change that made signals not update when the value is the same, because there's this ambiguity, because stores work the way they work today, but signals worked almost like event streams originally. Like they didn't have the equality check by default. You could turn it on, but it wasn't by default. And once I turned it on by default, I just got rid of this library, because essentially none of this works. Because if I change the source number here, or pass the same value, if I set it to 0 again, it won't trigger. Where for an event, you can pass 0 10 times in a row, and that's valid. So like right away, there's a fundamental difference between events and signals, in that signals conceptually own a value and there's no guarantees afterwards. You're like, look, I am what my value is. You're not saying there's no like I'm gonna have like a chain of like 0.006122222 in from the signals percent thing. It was 0, and then it was 6, and then it was 1, and then it was 2. There's no like, it doesn't care how many times you set it or how many times you propagate it along. But yeah,
it might have been 3 in between, but if no one was listening, then no one knows it was 3.
Exactly. Or with selection. Oh, I made a for component that I don't even activate. Oh, this is like a projection almost. What am I doing here? Apply class. It's like a wrapper. I don't even know what I was trying to do here. This is a problem when you get into crazy functional programming stuff. I never know what I was doing, because this example is the other reason I deprecated this library. Just on a side note, because I was like, look, create effect, transform, signal, filter. So get what even numbers or odd numbers, then times it by 2, and then tap, which is like do the effect console log. Or you could just go read the signal mod 2, or like to me, I mean, you guys can disagree, whatever. I actually find this easier to follow than this. Now, this is like the most negative way to introduce this topic. So, now that with that out of the way, what solid events?
Yeah. So yeah. So actually, I actually don't think that's a very negative way, because the kind of combination, the bunch of operators that happened that were there, that's kind of like a similar problem that I'm trying to solve. And yeah, so you mentioned that signals are very different from event streams, and this was something that took me kind of a while to fully wrap my head around, especially because as I was going back to like Elm, when Elm had signals, or like when I look at anything that has to do with like functional reactive programming, like if you look at like how Elm talked about signals, or even how Adam Hale talks about signals in SJS, they do talk about it in like the event stream sense. Like it's very heavy push based. It's something that you reduce, or like you reduce all the changes to accumulate state, and like that's very much the idea that I get from them, which is very different from how Solid treats signals, and especially how reactively treats signals. So there's like a very like it used to be eager push based, and then over time there were like we incrementally made it more lazy, more pull based, and into something completely different.
It's a funny thing, because it's so funny, and I feel bad to Adam for this, because like he was like guy all into like the like French late 70s research, SFRP, like all the like old synchronous reactive programming, like stuff, and he built a library, and he figured out how to make it performant. One of the rules of SJS is that like you can't set more than once within one cycle. Like it has these guarantees, and because of that, he could do some really smart stuff that drastically improved the performance compared to any reactive library that existed at the time. And like he did all that, and his base primitive, the signal, doesn't have the value check. He had S, which is the signal, and then he had S dot or data. He had dot value, which does the value check. But I just wanted to like call it a thing. So I was like, okay, I'm going to name my thing Signal, because I don't want to use observable, because at that point, freaking RX was really big because of Angular. Yeah. Everyone was talking observables, because observables are stream. I need a name for something not a stream, even though technically his signals were kind of streams. So like, I was just like, observables are already streams. There's a TC39 observables proposal, all this stuff. I'm just going to use the name Signal. And I threw away my original implementation of my signals library, which actually was based on TC39's observable proposal. I threw it away. And then I was like, actually used SJS for our base until I ended up forking it and changing the behavior. as in making it not do the value checks by default, making it allow multiple writes, basically turned into MobX, essentially, in terms of semantics. Ironically, MobX called their things observables too. Knockout called their things observables.
Yeah.
And it was really annoying because, in my opinion, all the reactive libraries that called their signals observables had all died out, except MobX, arguably. But RxJS was like clearly observables, and these were not the same thing. Really thing. So I sided with the RxJS side, funnily enough, and I was just like, I'm going to call these things signals. And now that's what signals means to everyone when it has no connection to the academic baseline, and and basically, I don't know. It's just we needed two different names instead of like this ambiguous like people using whatever names they wanted. So, anyways, that's my signal story.
And I really appreciate it because that's what I thought when I looked at like Elm or SJS or these ways of doing like reactivity or even RxJS. But when I went further back into like where FRP even came from, there were always two primitives. There was a behavior there and there were events. And behaviors were like these continuous values that like they change over time, or like you can listen to them at like two very small increments of time and their value can be different. And it's because they were used for animation, right? And in animation, you want kind of that vector graphic thing where like you can scale it infinitely up and down, you can move it around. So having continuous time is very helpful. But as like we tried to do similar things for app development, and it kind of felt like we left one of them off. So like we're only going to use events. We're not going to use two primitives because we don't have any need for continuous time. We're just going to grab events and build everything on top of that. So that's how I saw, okay, that's where RxJS and Elm, that's where they come from. But then we started calling those things signals. And over time, we evolved signals to look more like the other thing, which is what behaviors were, which were these like continuous pull-based values, which like you don't have an exact mechanism of change. You just like listen to them and they might change at a different time. So it's like this one term pendulum all the way from like meaning events to meaning behaviors.
Right. And behaviors is just the worst possible name anyone has ever come up with. I mean, let's face it. Or behavior subject or subject. The event means something. People understand what events are. Somewhat. Behavior, subject, those are both names are terrible. So now we have signals. So, yay.
Yeah. So we have signals. Yeah. And then like as soon as I realized that signals represent behaviors, I started thinking, okay, what do we have that represents events then? We really don't. Everything, like we just have event handlers that you invoke an event handler, it might call something else and it might set into the state. And at some point you were showing off on your stream like your new proposal for Solid 2.0 reactivity where you split the effects. And you were trying to communicate like some sort of duality that showed up when you split your effects, because now your signals return two functions, pure and ineffectful, and now your effects have like they take kind of like those same functions, the pure and the effect. And that's when I kind of realized, okay, this is the other graph, this is the event graph, that's right, where it needs to be. So that's kind of what I was trying to build, is that okay, we have this pull-based primitive, we have signals, but we need something to represent this other side, this mutation side of the graph, or the event side of the graph. That's what this is trying to be. That was a very long-winded intro to this.
I mean, createEvent is just a basic event emitter. This looks like in Node, we have an event emitter, right? This is similar, right?
Yeah. So at some point, I even had like something like createEffect. So it's called createListener, where you would pass in the event itself as the first argument, and the second argument would be the side effect. I want to bring that back for reasons that I'll get into later. But right now, here you see that there's a console log on event, console log something, right? You would do this using a listener because it's a side effect. You wouldn't just directly pass in a side effect into the handler. But for right now, this is how we're doing it.
Okay. I mean, because this does look like a simple event. Everyone's seen, node event emitter, right? Like this, the API is slightly different, but it's like new event emitter on. I mean, these are named, I guess. So this is like with an event emitter, you can have multiple named events where this is only a single one, but it's like the same kind of concept, right? Emit,
Yeah.
and then on this, right? So, okay.
Yeah. So a couple small, like obviously I made it to look like a tuple, or I made it to look more like signals by doing a tuple. And the other thing is that these subscriptions are created inside SolidJS roots. So if you dispose a root, any event subscriptions that were made inside it are also removed.
Nice. Okay.
So that's the first
convenient.
thing. And then the transformations is where like the composability comes in.
On increment. So you create an event. Okay, on increment this, on message. Oh, okay. I see. Because these return, like they don't have to be effectful. They actually return their value as a function that can also be called with the payload. So on message will call. Interesting. If you pass it a callback, it will call it with the payload that comes from here. Right.
Yeah, it's just a map.
Yeah. Okay. Disposal.
This is what I talked about, that when the root gets disposed, you dispose the subscriptions. So all of these get created inside the root. And the halt is how you do filtering. So you can, inside a branch, you can say halt it right here. So now it's not going to propagate like on any events, like events further down the chain.
Okay. So this is something else you import. Okay.
Yeah, it's a little helper. I didn't want to make it an operator. I'm trying to avoid operators if I can. So just use helpers like these.
Yeah. No, operators is one of those things. I remember at one point RxJS shipped with like 120 of them, and then they're like, we're down to 45.
Yeah.
Like we're in a good place, and it's like, yeah. I mean every time someone's tried to standardize, it's been a matter of trying to reduce the number of operators to get started with.
Yeah.
Okay.
And there's going to be there's a lot of stuff that things like RxJS operators can do that you're going to need to do this in this model. Sometimes they'll require a bit of complicated logic. Sometimes I'll just say that, okay, convert this into an Rx observable, bring whatever operator you want or chain of operators, and then convert it back to an event so that you can pipe it into signals.
I see. If you return a promise from an event callback, the resulting event will wait till mid until the promise resolves. In other words, promises are automatically flattened by events. Okay. Interesting. Okay. Interesting.
Yeah. So so if you do an async operation inside the event callback, you just get an event back on the other side instead of an event of a promise of the value. This right now, there's like a couple different ways to do this. You can do something like called merging, where all the async stuff happens immediately, which is okay for like mutations. You don't want to do data fetching this way, because with data fetching, you want to cancel the previous one or avoid like getting its event back, which this doesn't do. So this is one of those zones where I would probably end up bringing some operators, just because like async events, there's like 3-4 different ways you can handle them, and each of them have their own use case.
Yeah. I was thinking about the get case, because it's like you don't like, this kind of sneaks away from like suspense. Like you kind of burying the lead here a little bit. I mean, it's fine when you're trying to, like, as you say, do an action, like it's part of the transformation that goes from like event to do the thing. But when it's on the read side, it's awkward. UI doesn't get to play along with this.
I'm hoping this can be hooked into suspense at some point, but that's that's 2 iterations in the future.
Yeah, create subject. Okay.
Yeah. So this, I just borrowed this terminology from RxJS, but this is basically how you combine your event streams back into signals, so that you can have a UI on top of it. The original FRP in the its specification in Haskell, they called it this a switcher, but we also know this as a reducer. Like there's a bunch of different names that you can call this by. But basically, like an event happens, you mutate the state. That's it.
Interesting, because this here is a chain, right? Like this is actually like this is the 0 is the input to this, which is the input to.
So it's not it's more of a merge. So
Okay.
the 0 is the default value, and these. So initially, I had like you update a subject with a single event, but and then like I had a different mechanism to combine a bunch of events into a single event.
Right.
But I realized that every time you have a piece of state, you have a bunch of different events that change it. You don't just have one event that updates that state. So I just made this like, okay, you pass in multiple events, and each of those events has a mutates its or changes
Okay.
the state differently. So
Gotcha.
when there's an on increment, you take the delta, you take the current count, you add them, and when there's an on reset, you just set it to 0. So
Gotcha.
those are
Okay.
different events that change the state differently, and the first
Right.
argument is the default.
Gotcha. And then we basically get a signal out on the other side.
Mhm.
Okay.
This to me was like as I was looking at like create async and everything that's like happening with reactivity, create projection, what I realized was all we are trying to do is get rid of setters and effects, because those are the escape hatches. It's not just that effect is an escape hatch, it's that create signal is also kind of an escape hatch, because we are setting that signal on our own. Like we want to avoid both of those, not just effects. So I looked at this in a sense that it gets rid of the setter. We don't have the setter anymore. We have a very predictable way of how signals update. All of that, like all the definitions are right there.
Yeah, that is one result of this. When you're right. Create async not having mutate is very intentional. Create projection, getting away from people writing effect to store. Create memo, everything is trying to do the directionality so that the write isn't on the outside.
Yeah.
Events let you basic event system lets you just chain right along there in a derived way, right from the, like you enter the reactive system, like the pipe, much sooner. Essentially, most of the time we enter the pipe like in terms of like an event handler, we write a bunch of imperative logic, and then we do multiple changes, and then that's where the entry points are. This is like often like a single event that comes in, or maybe the multiple events, but you basically almost immediately go in without the imperative logic. Okay. Create subject store, create async subject.
Async subject is basically like, it wraps and create async, which I'm probably going to remove. I don't need to have this primitive. Subject store is the interesting one though.
Okay.
So it's the same idea, but with each event, you don't return a new value, you mutate the current one. So it's like create projection, but you have multiple functions, one for each event that you want to mutate the store.
Yeah, I think it's almost time to talk about what I wanted to talk about with projections. So this got me there, but let's keep on going on here. Create topic. What's a topic?
So this is less way to combine multiple events into one. Again, I can come up with probably better names, but so you have on increment, on decrement. You just want one event that emits when any of those do. So like combining events into a single one.
Okay, so this is like a merge, create partition.
And partition is the other side where one event and you have a condition, you want to split them.
Right, okay. Merge and fork. Okay, use cases, state derived from events. Yeah, this is a classic.
Yeah, this is what I was talking about, where you enter what you said, where you enter the reactive state or the reactive system much earlier. So here you enter it as soon as there's a button on click instead of
instead of having a handler that calls the signal. And here you go emit increment, and then it ends up on increment creating the subject that does the count. And this is also where it's like my oldest kind of joke on Twitter is like sometimes people from the Angular side would show like this really well thought out RxJX code that was like really clean, and you could see like all
Yeah.
the stuff piped together, and they're very proud, and they put it there, and they're like put on Twitter, and they're like, look at this is why Angular's the best. And then you look at it and you're like, I could
What is it?
write this in React in like 1/4 of the lines of code, and it actually would
Yeah.
seem simpler. It's like what I showed earlier. This is a basic example, and you can already start seeing the bloating. The problem is when you need this, when you have retry logic, when you have more complicated processing, there is a tipping point, and after that tipping point, the more imperative looking logic starts going downhill really quickly. Like it's like a cliff, where this will scale till infinity relatively well. Okay.
Yeah.
Event composition.
And this is I didn't know what to call this section. This is where that kind of gets. I try to highlight the exact thing that you're talking about.
Right.
This is the drag and drop logic from Trello.
Yeah. This is drag and drop is actually the classic thing people always do with RX. Yeah. So yeah, do, and then yeah.
I can still make this like probably more cleaner, the event version. This was kind of written in a hurry because I was trying to get the submission in, and this was like 3 a.m. in the morning. But yeah, I can likely like make this whole section a lot cleaner. But here you can see that except drop, which had like its setter like all over the place. Here you can see, okay, when do we accept a drop on this element?
Yeah, quickly and share. We need diagrams here. Yeah, I mean, this is why
And
RX
that's the
has
thing.
those.
Yeah.
RX has those lovely little, what are they called?
Marble diagrams.
The marble diagrams. What's the current subject here? If you're just joining in, we already talked about the WebSocket stuff. We are now talking about Solid events, which is the whole other side of reactivity that Solid doesn't concern itself with. So Def made a library giving these capabilities. So we're looking pretty deep into the API surface of it. Optimistic UI.
And the thing about needing diagrams is that you can a lot of time you can generate those diagrams by either at the runtime tracking what events depend on what, or even just static analysis. So that's the other zone where basically statically analyzing these events and like knowing them at compile time. And there's a lot of optimization that can come out of that as well, which I have not written about or thought too much yet.
Yeah, it's true. It's part of the reason that things are harder to write is because all the points are explicit, like all the switching points, all the like with imperative logic, you will branch just like conditionally in the middle of something. And signals pride themselves on only tracking the parts that matter or whatever. With RX, you have to like pull all this, like, or events generally, like conceptually, you kind of pulling all the dependencies out to the front and hoisting them. So when things fork and you want to make sure that like only on this do you go this path and it depends on these things, you basically have to hoist it all out and split into different compositions to get that same level of granularity and do that. It's much trickier, but on the positive, it's literally what you see in front of you. Like there's no implicitness about how branching or forking or halting or any of that happens. So from that point of view, it is completely analyzable by a compiler, and interesting problem space. Definitely.
Yeah, I'm really interested in what resumability can look like with the event primitive like built in, or something that the compiler recognizes, because resumability is all about event handlers. So if each event handler chain is made very explicit in the components, it might be easier to like just pull it out.
Yeah, it's tricky because I mean, I guess we did talk about this in that HackMD, because like it's like where you enter and where you do the switch in terms of consciousness. Like in terms of like, here's an example. The benefit of going directly to the event is you basically remove all the closures, like by its very nature. Like, because I mean, maybe that's not completely true, but all the closures are explicit. is better way to put it, because you're not wrapping over values. You're setting inputs that feed into the pipe. So in a sense, if you had a system that was completely event based, you could maybe actually get away from the complexity of the compiler thing. Though, as I said, if you forced everyone to write their code like it all the time, you would have people. Actually, and Dominic's probably not here anymore. His earliest version of Octane was kind of like this. He showed it to me, and I was like, man, like this would make resumability like a non-issue, like, because everything, all state got fed through any handler. Didn't matter if it was like a signal or an event or whatever. You always got the state fed through, so it wasn't a closure thing. So yeah,
that makes sense. This still has closures though. So if you scroll like a little bit up, there is a, like, you do read from signals within these event handlers.
Oh really? Did I not see?
Yeah.
That?
So actually, it's right there in the on drag. It's in the drag and drop example, because when you're deciding, this is the imperative one. If you go down to the event version of this. Yeah, right here. So on drop node, you are like calling except drop. So
yeah.
So you read from signals within these event handlers as well. So that might still be an issue. Like, you still do need closure extraction, I think.
Okay, fair enough. Yeah, because there's always going to which is a little different than what I was talking about, where all the state fed back in. Okay, so yeah, you have lots of examples in here, which is really cool. We already saw stuff with that, fine-grained mutations. I like that the Strello demo is used a lot in these examples, because this is the double effect update that we talk about.
Yeah.
Fine-grained additions versus reconciling the board. Using subject store.
Yeah, this is where like the idea of events was like completely independent. But after working on Strello demo, or actually like before I did this, the optimistic implementation for Strello, right before that, I realized that, okay, this events library that I have will actually be perfect for like optimistic mutations like this.
Yeah, it's actually interesting, because I had this discussion. Milo actually didn't like Create Projections API and almost wrote this API word for word. It's funny. I feel like pulling up the Discord. He wrote like create projection this, and then said on mutation. That I kid you not. I had this discussion with him yesterday, and he was like, "This would be better," and I'm like, "I'm not sure." I guess the concern was I was not picturing, or neither of us were picturing multiple events, but this actually is probably the key to it. It was this is actually kind of funny seeing it in front of me right now. I'm gonna make a note for Milo. But yeah,
that was my thought as well, because the split effects and like the branch has updated, which was the demo that you had with Create Projection, or at least the snippet, not the demo. And all I could see when looking at it was that there's two different branches happening here.
Yes.
But the condition is implicit, or it's like we're trying to figure out the condition while we're inside the function. If we could just make that more explicit, we can have two different functions that do this.
Yeah. It's interesting to kind of push people that way, but then you're like, is it generalizable? Because the whole idea for people not following is that there's the original thing that gets the source, and then on any of these mutations, it tries to do, like, the thing that's might not be obvious here is when you're dealing with some kind of projected store, some kind of like fine-grained thing that you want to like mutate or update in this kind of derived way, you're basically always doing a diff. Like, no matter how you look at it, even if you're just trying to find ways to do it more optimally. Like in this case with these mutations, we know that we can create a single node, move a single node, edit a node. These are very specific operations. But when you don't know you update some data and you don't know, all you can do is diff it. You get new data from the server, all you can do is diff it. So like all these specific mutations are just to avoid diffs. Like in this version up here, essentially you're like, okay, these are specific mutations, I can do them one by one. This here, it's because the board updated, I am going to do a diff. See, reconcile, that's do the diff. So like essentially there's this kind of weird, like here's two effects, it's separate, but what I was trying to do was get rid of the effects and make it into a derived value, which create projection. You basically are always diffing. You actually have to worry about sorry, we're going to tangent for just a second here.
Let's do it.
What I wanted to just kind of conceptually go here. This isn't going to be actually running code for a second, but if you saw something that was like this, create projection, and let's say it gave you the store, and I'm sorry for people who aren't familiar with this API, I've been talking about it for weeks, but the idea here is this is a derived way of updating something like a store. And because stores need to be granularly updated, we have to actually track the updates granularly. It's kind of like immer's produce function or whatever. So the thing is, if you had something like this, store.a equals, signal a, so like you're basically saying whenever a changes, I'm going to update store.a. This is usually the example. But if you said store.b equals b or store.b push b, okay? Do you see, like, you see why this could be problematic?
This is happening every single time.
Exactly, right? Like if you are making a memo, let's try this again. Const m equals create memo, something like derived, and you have previous, and you're doing this. Well, what you're going to do is you're going to say, okay, I can one line it actually. It's you do this. You go clone previous a equals a, b equals. To be fair, the fact that we're recursive, maybe this problem happens with any kind of recursion, but like you have to be aware. Yeah, it's interesting because this also does it too, doesn't it? If you think about it.
Yeah. Like
previous.
If A updates but B didn't update, you have two copies of it now.
Yeah. So like you almost never write, like this has to diff essentially, or here this has to diff. Here usually you more than often what happens is memo always returns the next state. So like you just make it the state you want it to be. Here you have to actually change it to be the state you want it to be. Here, like, I don't know, there's a slight subtle difference between knowing the previous state and having A and B and knowing what the next state should look like versus, again, having the current state. Yeah, I guess it's not actually that different. I was trying to like think in my head if there was like something.
We need a different example. I'm trying to think of it as well.
Because like conceptually the whole problem with this is that like if A updates and B doesn't update, you're still always pushing B, right? So it's kind of awkward. I think we kind of understand this now. So I think people avoid this. Generally speaking, they don't write code like this, but it is something that like you have to be aware of. Like if you're creating a projection where you're updating state and stuff, you're basically doing a sort of diff. You're like, okay, I have this new data. The way Milo put it to me was he was pretending like this was an update function, like a produce call, and he said to me that this update like, and I shouldn't use A and B. I should use like 1 and 2, like different values of the same signal or set of signals. Like assume that these are should equal update 2. Was what Milo put to me. Like, this principle has to kind of hold, and which is
Interesting.
right, because like this is a journey and this is a single update, but at the end,
Yeah.
like, that when the state is in state 2, you want it to be in state 2. The journey shouldn't matter.
Yeah.
And the only way you can do that is if you diff of some sort in here. And I don't know if this is like obvious to people. Like, every time this is why when you write code, like the example in here, this is 2 different effects, but if you were to combine it, let me see, HackMD, I think it was something along the lines of no. Older? God, how long ago did I write about this stuff? Derivations as first principles? That sounds about right. 5 months ago?
Yep.
Jeez, how long have I been
It's
working
been a
on this stuff? Okay, well, yeah. This is the projection version of that code, right? Where you do the timestamp, you ask if it's updated. If it has, you go the one branch and you reconcile. You do the diff, or you go the other side where you do it one by one. You have to
Can you bump
understand.
up the font size?
Yeah,
So,
let's do that
chat.
again. Yeah. Let's look at this again. Basically, you have to understand here that, like, this is very clear. It's a diff reconcile, like 100% doing a diff. If you go down this path, you are doing a diff. Good. But on this side, this is the key to the whole thing. You aren't doing a diff exactly. You're optimizing away a diff by knowing that you've already processed some of this list, right? So we use a timestamp. You could say, like, done processing. You could say, like, hey, mutation, as soon as you've been processed, done. Like, there's other mechanisms for trying to make that decision point. But in a sense, these are both sort of diffs. You expect that whether you got the first mutation and then the second mutation, or you got both mutations at the same time, that you'd get the same results. And if you look at the actual function we use for inside of the Strello demos to do it, we do things like call push. Like when we get a new one, we push it on. It doesn't have to be immutable, but like, we have to be careful that push only gets called in a specific thing. And to be fair, this is no different than createEffect, to be fair, or createMemo. We generally try and prevent things from over executing. But when you consider things like transactions and forking stuff, it's going to be possible. Because I was talking to Milo about solving this, and he's like, "Oh, Ryan, it's really easy. You just run it twice. React strict mode, right?"
Right.
I'm like, that's like, do you want people to hate you? Yeah.
I mean, you're turning more. Solid is turning slightly more into React with 2.0 anyways, so might as well.
Yeah. I mean, it was just one of those kind of funny comments where, well, 2.0 does have that aspect because the effects pull all the way down when it comes to a scheduling thing. Like, anyway, but I'll talk more about that here. I still got you here. I wanted to talk about this one while you're here because it's very close to the area that you've been working on. But yeah, imagine splitting effects into multiple effects at compile time if no other reference from the scope is used. It's a huge problem. It's getting pretty confused fast. You can't do it. Yeah, and it's kind of interesting because on one hand, you want to split them, but then you increase the creation costs. Like, I'm pretty sure Svelte and does similar stuff to Solid where some level of effects are combined, because if you make too many effects, it starts adding up. I could be wrong. You guys can correct me on that. So, like, I was playing around. That's what this whole has updated a lot since run. I've actually implemented this in the 2.0 logic. I told Milo, and he looked at me very horrified. Like, this was like a property that, like, was unsafe. He's the academic one. I just make things work. But like, it's like, this is a trick because you could literally go, this equation could be, instead of checking the value, you could actually skip the whole value and just go like, hey, has B actually updated? Like, not even has the value changed. That's an easy one, but actually you could probably avoid even executing B, right? This solves Fabio's, like, he gets very upset that the random numbers, because when you group effects and you have like math.random in the middle of the effect somewhere, it's possible, because every time it reruns, it'll, even if the specific thing didn't change, math random will change. And I'm like, look, we do our best, but like there is some amount of like extra stuff going on. Like we're not going to, like, everything isn't necessarily 100% the fine grain. What we can guarantee to you is that we're not going to recreate a bunch of extra DOM elements, and that we're not going to do stuff. But like functions may run, more than they have to. It's like there's like that small portion of the time where it's not fine grained for a different reason, but you're not going to observe it except for if you're like counting the number of times this function ran. And not even a function.
Sounds like React compiler.
Yeah, exactly, right? I need the React compiler to hoist out his math.random, But what I'm getting at is like it's at the most granular of levels, like the final bindings. It's not in your code. Like it's only in the JSX that this happens. But this could solve that problem.
Yeah. But yeah, it was a very similar observation that I made, which was there's always some sort of a diff involved. Either you reconcile the entire state of the board, or you have something that keeps track of what actions you have already applied, so that you diff and you figure out, okay, these are the only ones that need to be applied. Or like you have something like updated since last run, which like, okay, it has this value updated since I saw it.
The way I'm actually doing it isn't actually the value. I'm using clock cycles inside the internals of the reactive system. So it actually is like, it can do it without checking the value or running, which sort of answers your question here. Yeah. Paulo confirmed. Yeah. Svelte does the same basic thing that Solid does in terms of template grouping and stuff. Yeah.
Yeah.
So
yeah. And the point is that in like that, this sort of a pull-based system, that's really the best you can do. Like you have to check against something, but with push-based, you get to kind of like circumvent that, because you have a very specific instance where everything updates, and you have a very specific reason for what needs to be updated. You do need to check for like in the create node update, there is a check like, has this node already been created? So you do have to kind of like maybe like you want to call it idempotency checks. But other than that, event happens, you mutate, and that's it, which is really convenient for stores.
Yeah, I mean, it's got to be on the right portion of the code path to make work well, because RX does classically have this problem. The reason the Angular people like jumped on signals, it felt like it was not the true story. We already did that on my previous stream. I was talking with Pavel and Alex, where it was a long journey to get there. But like from their community perspective, the reason they're just like yes is because they were using RX for so long on the get and fetch side, and they would have things fork and then remerge again and trigger twice. Like the loops and the cycles drove them absolutely nuts. But where RX fits really well is not on the get side. It's actually on the path from the to the post. It's like from like the user action going back into the reactive system is probably the most powerful place for events. I mean, there is transformations on the other side coming out, but the place that's like uniquely interesting is actually going back in.
Yeah, that's exactly what I'm trying to build here, because like signals, they exist, they do a great job. I don't want like RxJS like with its own state primitives, behavior subjects taking over that. But like, what is one use case that we can, what are these like specific use cases that we can solve with events, knowing that we already have signals on the other side?
We really got to thank Ryan Florence, I think. Sorry, this whole Trello demo thing that like not only spawned the whole create projection work and the whole mutables work. I mean, it's funny. I have some notes from like 2 years ago in my HackMD that I'm just like, feel like I only thought of this, like a couple months ago. It's like, no, you've been talking about this for like 3 years, Ryan. But that demo just like accelerated everything forward. Like it's like used in all these examples, and like talking about this kind of situation that bridges even with the WebSocket and the local first stuff. This whole idea of like fine-grained projected or derived data is a very interesting thing, and I'm very happy for that demo, because without it, like we already did single flights. Like the single flight mutation was inspired by the React Server Component Notes demo. This one though really inspired this whole granular like zero, I don't know what to call it, zero work diffing or like mutation optimistic update approach, which, as I said, hasn't been matched really in any of the other frameworks. And we haven't even just done that. We were actually, you've come up with different ways to represent the same space. It's like, it feels like it's a thing. So yeah, Ryan Florence, big heads up for making us like look at the problem, go, like, here's the problem. There is something legit here. In React, you kind of just forget all of this, and you literally just like kind of like, you just write basically the first one. You don't write this in React. Like, you don't even have to do this. You basically just go here, clone the notes, apply the mutations, and then stick it into my VDOM. So in Solid,
you can remove the untrack and the reconcile.
Yeah. In Solid,
and that
basically what you could do, Solid's version of it is a one-liner. You just say reconcile. Like React, the reconciling happens automatically in the JSX. Here you have to call reconcile. You could just say like here we did them separately. It could have reconciled the whole board. Doesn't matter. So here we just call reconcile. So it's a one-liner. So to be fair, the Trello demos in React look like apply mutations into the JSX. In Solid, it's apply mutations, reconcile into the JSX. So, it's a little bit nicer. But we add this little bit of extra code here, and it completely changes the performance aspect. And then maybe people don't care about that much, but it changes the performance and execution aspects in like a dramatic way, in my opinion. Like, obviously, no one's probably spamming this, but if the Strello demo was dbmon, like Ryan Florence's original demo, the Solid version would be absolutely demolishing the React version in terms of amount of work getting done. So, yeah, it's interesting. And this little bit of code is less than the incremental Signia approach in React amount of code. So, yeah, I'm just glad this example exists. It's like, it's on my list now, right? We have TodoMVC, we have the JS Framework Benchmark, which is basically super TodoMVC. We have Hacker News, and we have Strello demo. So like they each show something different. I think this one's officially on the list, so to speak. So very, very cool demo, and big shout out to Ryan Florence for getting people to all build their own versions is quite a journey. And then you have a whole alternative reality where you try to use RxJS. I think we talked about this stuff earlier. All right.
Yeah.
I don't know. I think we're pretty good on what I wanted to talk with you. Was there anything else you wanted to share? Or I'm also giving the audience another chance to ask you any outstanding questions.
So I have, there is something that Dave and I have been cooking up, which I would love to hear and get your thoughts on.
Yeah.
So it's an idea mostly inspired by VeedConf. It's like a conference around signals, fine-grained reactivity.
Nice.
And one day or 2 days of content from like community people, framework authors, implementers, people in companies who are using this.
It's general enough to do it, and I love it. It's hilarious because you need it. You need the audience pool to be big enough to get enough communities in. But then it's like, how do you tie them all together? Because there's like JS Nation, right, where it's like everybody. But the only thing that's funny about it is it's like the not React conf. Like JS Nation ends up being that way because it's like literally next door to like React Summit. But you're suggest so it's like because like who'd speak at Signals? We have Svelte. We have
Anyone that's
Vue.
not in React. I mean, I was
Solid.
thinking like even like sending like reaching out to the React compiler people and like, hey, it's just about fine-grained reactivity. Come talk about compilers.
I mean, you're right. Actually, fine-grained reactivity. No, it's fine. It's not actually not React. It's interesting, but yeah, the compiler would be fair game. You also have all the state library people, Legend State, MobX. Yeah, so yeah, I mean, it's an interesting thing. If you pull it together, that's pretty interesting. Will Terminal be there doing something weird?
If you want to, sure. I mean, it's a virtual thing, so probably not as exciting.
Yeah, MobX. Yeah. Yeah, interesting. Yeah, yeah. That's interesting idea to put forth. Got signals.
Yeah,
This is the first me hearing it. So yeah,
it's like a very fresh idea. Like I started talking to Dave like maybe 3, 4, 5 days ago. I actually had a call with Patak. I forgot his real name, but like how he runs VidConf and like get some ideas from him as well. But there's something that I'll try to keep cooking and see where it goes.
Yeah, no, I mean that's definitely very exciting, interesting. There was actually a question earlier in the chat. Someone was asking if you'd figured out how to spend your solids hack money.
Yeah.
Somebody I think it was Jay Larkey, probably.
Yeah, that was him.
Matthias,
yeah,
yes.
Matthias, thank you.
Matthias, or yeah,
Matthias, sorry.
Yeah, whichever way it is. I'm sorry.
No, I haven't figured it out yet. It's probably just gonna go to repaying my education loan, even though it didn't come out of.
I think that's a fair expense for anyone. Yeah, no, we're good. All right, well. Yeah, I'm excited about that. Beyond that, what did I want to? Oh yeah, right. I had some other matters of business we've been talking about. Your continued work with signals and server signals and stuff in the area of research has been very enlightening and really pushed the boundaries of what we've been doing here. So we do have a little bit of an announcement today. For people to know, Dev's joining the SolidJS core team. So a little bit of news. We'll get the website updated soon. But yeah, continuing the work and research into new areas. I know we have a lot more researchers on our core team than maintainers, but that's how you push the envelope forward to a certain degree. So yeah, very, very exciting.
Thanks. I am very excited for this. I'm very happy that whatever research I was doing was considered valuable enough for this.
No, you constantly are part of the conversation and pushing stuff forward, not just on the technical side, but in terms of even the DX and having communications, even like release stuff, bugs, even the contributions peripherally around solid start and whatnot. So like, just like understanding like where we're at in the ecosystem, and it's an important area. So yeah, very, very excited to have you working with us more on a more official basis. Not that it changes very much beyond that.
Thank you very much. I am not looking forward to. I do have to be, maybe I guess, a little less spicy on Twitter when I talk about React, though.
Yeah. I mean, that was the biggest reason to hold off on making this maneuver, because we wanted to. Love the tweets, but to be fair, you and Attila have been doing fine. There was one I probably didn't even like it, or didn't like bookmark it. I liked it, but I didn't bookmark it. Where you guys were talking about like the real benefit of the compiler or not. Aiden's been just hitting React so hard over and over again. So yeah, fire, definitely. Did you see that solid Meteor when?
There's a solid Meteor.
Is there already? God.
Sorry?
Of course there is. We have a giant...
Yeah, I posted in the private chat.
We have a giant ecosystem of every library you can think of. There's a solid library, right? There you go. Oh, okay. Yeah, I mean...
I think...
we've had this for a while. I know the author of this one. Yeah,
And
there you
I
go.
think this does tracking beyond, like, if you
3 years ago.
use a Meteor tracker inside a solid effect, it automatically tracks it as well, I
Yeah,
believe.
yeah. He's probably using the arcs. We have a use external source, which lets you like use MobX natively in Solid or use a different reactive system. He probably
Right.
put Meteor in there. Yeah. So it hasn't been updated in 9 months, which is fine. We haven't updated a ton of stuff on the core. This is probably like 1.8 time period. But essentially, yeah, 3 years. There you go. So all the hot libraries here in Solid ecosystem. Good stuff. Good stuff.
Yeah, thank you very much. I'm very happy to, and very excited to continue like working with the team and seeing where Solid goes next.
Yeah, definitely. Great to have you. Anyway, I think that's it for dev on the stream today. I'm going to continue on a few other topics that I've prepared because I haven't done a stream forever. Thank you so much for joining us. That's awesome. To like talk to you next. Catch you later.
Thanks for having me.
Yeah. That was pretty awesome. Stream's not over yet. I have a couple topics I want to go over. I don't know if this week in JavaScript will be much of anything because I really haven't been paying attention for like a month. I've been on a crazy deep path looking into stores, and because since the last stream, which I think probably a lot of people didn't even follow exactly, but I'm actually pretty happy on the results of that. So I'll talk about that in a minute. But yeah, no, Dev's work has been really really interesting, and constant voice presence out there, kind of giving benefits of using things like signals, another mad scientist. Yeah. Yeah. Hopefully, we do enough of this stuff sticks and hits the wall. We've been, it happens on all levels is the best way I can put it. Because like, right now I'm doing a loop around back to the core of things, whereas like we went all the way out to the depths of the lengths of like solid start. So having people doing R&D, continuing the R&D on the like I'd say like the server signal stuff is pretty far out, like in the solid start kind of range of stuff, versus like the work Milo has done on like reactively and the really core reactive stuff, on the other side. We constantly have to like explore all the different patterns and then figure out the right time to kind of integrate it all along. And I'm very excited because we're like basically starting up a new push, back around. All right. Take a deep breath. Drink the last sips of my coconut water. Okay. So, yeah, I got a couple topics to talk about today, in addition to what I'd covered there. As you can imagine, I've been working on. Oh God, I have even more topics than I even realized. Typical me. I won't cover them all. Probably. Let me share my screen a little bit here. But like, I realized like Tanner sent me off on a weird goose chase the other day, where he wanted to know if lakes were real, essentially. So I like started hypothesizing. This is about server components. I don't know if that's a topic that's interesting to anyone. I'm pretty sure this was. I talked a bunch and made no sense on the store stuff last time. I actually found a solve though, and I'm actually really happy to talk about that today. So maybe that's where I'm gonna talk about, and then maybe I'll talk about hierarchical reactive scheduling boundaries. But yeah, basically, I realized that all this work that I've been trying to do for stores to make them performant, and make them like work well and not mutate and mess with stuff was basically I was trying to make stores something they're not, right? We spent the last stream, we looked a lot at like Immer, and we looked at, so this is kind of like a follow-up to the previous stream. We looked a lot about like diffing and patching, but if you think about it, I might need the Excalidraw for this one. If you think about it, I'm trying to think of the best way to kind of lay this out is, if maybe I'll start in the playground. It's probably easier just to like just delete some code and just write some lines under. If you have an immutable system, what you'll generally do is you'll have like, let's say I mean, this is Redux in a nutshell, but essentially you have like the previous state and you have some kind of other input action, whatever you want to call it, to get the next state, right? So this is how you're going to generate this next state, right? And then later on, where you do the connector piece, what you end up doing is you go diff next against previous, and then you patch. So this will give you like, I don't know what to call it. It's like the encoded. We'll call this the patch, and then we'll call this apply patch to whatever the output is. I'm going to apply the patch to it. This is kind of the cycle that you have when you're dealing with immutability. So what ends up happening usually is that next, anything like along the tree, which is where I'm going to get here. Let's pretend we have, you know, these data nodes. Let's give them a color. Okay. All right. And you've probably seen this. My arrows both directions. Let's, oh, it's because I'm zoomed way out. Probably should have, this is the problem. It's like, if I keep on zooming way out, I'm gonna make something here. And then we're gonna do this. I probably showed a version of this. Let me see, turn this into that. I feel like I showed a version of this, but it's been a month, so I'm gonna redraw it right now. If you had a data structure that was nested like this, and you want to change this one here, so I'll keep it black. We'll go here. See, and you change this node, you know, so that you have an array of users which have properties on them, whatever. If you change this node, what you end up doing is you clone this and you clone this. These references stay the same, but you end up needing to clone these. So the array will now hold, that had 2 users in it, will now have an existing user and a new user. Even if it has the same ID, it doesn't matter. This is like the basic way you do immutability. You basically clone along the direct path of ancestors in order to make it work. And what this means is when you get around to diffing, which should be a surprise to no one, it's actually fairly easy to diff, because you can go, what you'll have over here on the diff side is you'll have a copy of this right over here. Let's see, can I shrink this whole thing down? Yeah, I can. So on the diff side, what you'll have the original, right? So you'll have this version. So do let me know if I'm making complete sense, or I'm sure you're probably already aware of this, but what you'll do is you'll have the original, and then you'll have the new version. So, you know, this is previous. Yeah, see, I'm way zoomed out. Yeah, so you have previous. Let's make that large. And then you have next, right? So, sorry, no. Yeah, so previous, next, some input changed it. And then when you do the diff, you're just like, yeah, I need to make these even smaller. Sorry, give me a second while I wrestle with my Excalidraw here. Right. So it's pretty easy to do the diff. You start from the top of the tree and you go, does this one equal this one? You're like, no, okay, something has changed. Then you go, you look at its children, does this one equal this one? You're like, yes, stop there. Then you go, does this one equal this one? You're like, no, something has changed. And then you go, check this one and you go, nope, these are the same, so you can stop here. And then you go to the sibling and you're like, oh, this has changed. And then there's no more children and you're done. So basically, even though, ironically, when you created next, you clone these, you then walk over and realize that these are the things that changed. And there is a different tree, let's say, over here, which is like, I'm going to call it the output tree. And the output tree could be like the actual DOM. So what you end up doing is, okay, you have the original, you clone stuff as you create next, then you diff it, and then as you diff it and go, this has changed, you go and update this one. So it's the same walk I was doing, but essentially you know from the diff that this changed, and then you go across and you apply the same change over to these different objects. The difference is that these, sorry, it's going to be a little bit different. These are, sorry, let's go to black, go to blue. These are actually, the reason you do the diff is because these start, we'll make these yellow in the end. These actually start as different objects, right? So I hope I'm making sense here. I realized my explanation a lot better as I finished it out, but essentially at the beginning you have previous and you have the output that looks like this. Let's say it's the DOM. It might not be one-to-one mapping, but you get the idea. You generate next by setting the inputs to mutate certain things, and you clone these and reconstruct the objects along the way. Then you diff them, and as you diff them, you basically realize that these things change, and then it's to create this patch, which is to say change this, change this, change this, and then you apply the patch, and then when you apply the patch, you go through here and you change these to yellow. Okay, essentially. So now it matches this, except these are not referentially equal. These are referentially equal. The thing to consider, and the reason I'm talking about this, is that when you create the thing for the first time, like it was empty, you end up constructing this whole tree in your first pass because there's no previous. So they're all red, right? And then when you come here, they're all yellow. So you construct it. You always construct two completely separate objects. You construct the diffable object and you construct the output object. So there's always two. So just in terms of allocations. And then as you continue to mutate things, you may construct, you may construct new objects here, but usually what happens over here is you may or may not construct new objects. This might actually be mutated. Like this might, like if it's the DOM, you don't necessarily create a new DOM node. Maybe you do, maybe you just update a property on it, right? So as I said, visually, this is maybe not the quite perfect comparison, but my point is that the most expensive operation is the creation or the adding of new nodes, because you definitely need to add them, like create them in the next, and you need to create them in the output. But then after the fact, as you do the diffing, it's only things that get created are these new intermediate nodes from next. And sometimes here, depending on what the change is, you don't even create anything new. This is the basis for immutability, okay? Hopefully everyone's following so far. Someone in chat just say that makes sense, just for my sanity. Hopefully that makes sense. This is like the base. This is like React at its core, right? This is like the last time you did the VDOM. This is what happens at the end of your rendering. And this is the actual DOM as we apply changes from it, right? So render, internally diff, and then apply it to the real DOM. Okay. So what about Qwik? Qwik is a VDOM. It would do this basic same thing, right? Even Solid does a certain version of this at a more granular level. Okay, so let's talk about stores, because you could also treat stores this way, because it, like Redux. Well, Qwik does certain things that are interesting from a serialization point, like in terms of like where the boundaries are, but mechanically it's like Preact is probably the closest framework. It does a VDOM with the opt-in of doing occasional granular rendering with signals. So like it doesn't fundamentally change the rendering part of it. Like it just changes the way code loads. Is like code is incremental, but the actual rendering, diffing, data management is similar to any other library that you've used before. So it's not like completely different here. Preact is a really good comparison because they both do VDOMs with the opt-in of granular, and I think that's almost identical. But where I'm getting here is Redux kind of works like this, because with Redux, again, it just does the first two steps. It basically gives you, like, it basically makes it very easy to produce the next state from the previous state. From there, you have to do the diffing yourself with Redux. You have to go, oh, did this change? Maybe in your React components, you check if the reference has changed. And the most tricky part is this reconcile at the end, because I said sometimes these turn yellow. Maybe we didn't actually have to replace any of these. Maybe these, even though these like updated stuff, maybe only like we only need a new one of these, right? What will happen, like maybe this one's new. When you get to here, this is all in React land when it's React, because what React has to do is go, oh, is this the same thing? Like, was it a div before and is it still a div? Or key, you know, the key property in React? This is where that part happens, where it goes, this has changed. The default behavior would be swap it with something new. But if every time you would have to create a new DOM node. But if you put a key and the key is the same, I guess the thing is in React, the default is it doesn't swap new. It's only if the key's different. If the key doesn't match, then you replace it. But the idea is if the key is the same, or I guess if there's no key and enough other things match, it will try and merge it, which means it won't create something new, it'll mutate this. That's the final output, right? This is why you have keys and stuff. Redux only cares about the first part. React handles this part. Immer only cares about the first part, generally speaking. React handles this part. Same thing with Signia. You'll see this pattern that React is actually the one handling like how to go from the diffing to the actual like output, like this section. Like React itself does this, but then state libraries like Redux also do this. And essentially the diffing and the patch applying happen kind of under the hood with React. But if we're talking about stores, we're kind of in an interesting point, because stores in Solid today are basically like if you only had this, right? Because it's more like this. Stores in Solid. It's more like you have store output, and I'll change the store to be using the nice green thing. Let's start over again. Stores in Solid. Okay, and then output in the DOM. Okay, so it's really easier with Immutable to see the three things because they always exist at the same time. Whereas when you have a reactive system, what ends up happening is there's additional arrows, so to speak. And I hope that I draw them the right way. But essentially, let's make them dotted. There's also arrows that are like this, essentially. Which is a little bit different than React or an immutable system in that I'm going to go to here. In that when we do the same change and we go, oh, this one has changed, right? That's what started it, right? We realized this had the change. They cloned. And then, yeah, I guess to make this example consistent, they realized that ultimately that this was the thing that changed, right? They first cloned this, then they diffed it, and then they reconciled it, or applied the patch, and then that was it. With the reactive system with store, when this changes, this is listening to it essentially, and this changes, and you're done. So you can immediately see like the positive benefit here, because like again, if this was say a React render tree, well, and these were components, like it doesn't matter what the structure is in this zone. Well, this component has to rerun, right? Even if this shortcuts because it's memoized, this one has to rerun because it's not the same. Because you need to get down here, and this one has to rerun. This can shortcut because it's memoized. But like if you change here, you have to run the whole component tree and diff it, or the Redux process, or whatever the hell you want to call it, because you lose that information. You end up cloning this, so you make a bunch of extra objects, and then you do like 3 steps where like this is literally change this, right? But the challenge is that what if you don't know it's just this that changes? What if you're in a situation where you do need to diff? And this gets kind of interesting because there's no previous, so to speak, right? Like if we take our example and we like, there's no even real next if you think about it. Like if there was a next, you would have to reconstruct the whole store again, right? Here they reconstructed it by making the next, sharing the references. I mean, you could do that. You could take this, and apply it to this. But the problem is, how do you diff it? Because you can't break these arrows. See, these arrows are fixed references. If you actually swap this thing out, this thing will be swapped out. You can't these arrows existing means that it's actually a pain in, like, if you were to switch this and make this red, you actually would replace this whole tree. Is the fundamental difference here, because this system depends on stuff running top down. This system depends on these arrows existing. So if you actually, we're fine in a reactive system because usually we just update down here. But if you change the story and it's not this that actually updates and it's this that updates, which ends up creating all, like if the whole thing is red, the whole thing gets recreated. Where there's a potential in this system, if the whole thing is red and they have the same IDs, React can still find from the key that it's just this one. Does that make sense? Like if you're in a scenario where next is literally all red, but the keys match, React can still output this. In a system like this, even if we wanted to do that, if you replace this all red, you broke the arrows, which means you have to remake the whole thing. And that is about the worst possible scenario here, right? So, okay, hopefully this still makes sense to people. So our answer to this is diffing this data. We have to keep the arrows. So if the way we can keep the arrows is if we diff a new value against this value and see that it doesn't change, that's fine. Nothing changes here. If we get here and we see a property changes, or sorry, if we see that, what's a good example? If basically, if we see that the reference has changed, but the key is the same, then again, we can choose not to. This is why we put the keys on this side when we diff. We can choose to keep it the same. And then finally, like when we find the one property that changes when we diff on this side, then we can apply it. But the key part, like the important part here is that when we mutate this, we don't mutate this. Or sorry, we don't replace this. We mutate it. Because think about it. If this is an object user and it has a name on it, and you've changed the name, in an immutable system, you don't change the name, you have a new user. But here, we need to keep this link. So we keep the same user and we just change the name on that user. So this is fine. We get the same fine-grained updates. All the links change the same. The problem is, if someone out here was keeping track of this previous object for some reason, like they created the store, like maybe when the store is first created, they had this and they say create store with this object. This change of name is now reflected in their original object. You actually mutated the source object. Here, you never have that fear in Redux or in an immutable system, because if something changes, the whole tree changes. It's completely replaced. Where here, because we need to keep these arrows, we have to mutate stuff in place rather than replace it, because otherwise it would break this whole part of the tree and we'd have to recreate everything. Okay. Hopefully that makes sense. And people are still following. Okay. So this is why it's very important that things that appear multiple places in the stores, things that can change order between different updates, have a key property or an ID or something to differentiate them. Because otherwise, if we come across an object, we come across like something here and something else is in the same place, we got to assume that it's the same thing and we merge them. But merging them could have weird consequences to people keeping references outside. It could have, they could be completely different objects and they could like change one shape into another one. I mean, there might not be any downside on what you see in terms of rendering, but let's say you're diffing things multiple times in a row. Every time you do the diff, you create the new object. Even if you're trying to do this immutable thing, you'd have old objects that have been changed, and you would have even like you get to a point where the previous state no longer is the previous state, where like this, let's say you did a change like this, where you did make a new version, right? And then it went here and goes, okay, this is the same object, so it mutates this one. The next time this one changes and it's a new object, or sorry, something else changes, this one changes and it's a new object. When it goes to diff on this side, it will still see these as separate, as different objects, because you mutated this one, you didn't replace it, which means that you will have to diff all the way down again, because there's nothing, like when you match a key, that's not stop diffing. That means these should be merged. You because they're not referentially equal, you have no way of knowing if anything has changed. Like because you can't make that assumption. In a system that's immutable, you know that if it's not the same, it's definitely changed. In a mutable system, you only care about the values. You can't know that. So yeah, and well, time travel. Everyone loved Redux and thought it was magical, was because you could literally time travel. You could keep previous state n, and you could just go, oh, I need to go to previous state n. And all you would have to do is grab previous state n and apply it on top of the current state. And then again, you could, because things that were still the same back in previous n would be the same, and things that, you know, were different would just swap again. You could basically go forward and backwards in time as much as you want because nothing mutated. Trying to do time travel in a system like this is actually very difficult because you mutate things. So you have to take snapshots intentionally, i.e. clone the whole structure probably. And then, so if you're doing time travel, you've gone from, you know, like, yes, the simple case is super optimal when you know the single thing. When you try and do a diff and you assume full ownership of the stuff coming in, that you don't care if it mutates, again, super optimal. But as soon as you try and do time travel, well, guess what? You're cloning every time. So quite often what people will do in these diff situations is they'll actually clone the input. So if we go back to our original scenario now, we've secretly added another tree here essentially, because we clone the input to get this state to do this state. So we're recreating this same tree essentially, in a sense, like from the React or Immutable standpoint, except the problem is this tree will always be, I mean, it's not previous, it's more like it goes in the middle, but I hope you get my point here. This tree, which is like the new input, will always be new nodes because you're cloning them and then diffing and then doing it, which means that instead of just cloning what changed, you clone everything. So this is kind of awkward because we make fun of immutability for being expensive because it clones like 3 objects, but this is worse. You don't only clone everything, because the only way the difference between these now, because they're different referentially, is to diff them every time. You do the maximum amount of diffing. You don't get the shortcut. It's actually just basically the worst case scenario here. So this is kind of bad. Obviously, if you don't need the capability that I'm talking about, stores are great because fine-grained updates, excellent, client-side only. Even diffing, where you always get fresh data from the server. You know, in that case, you're not cloning anything. The data is fresh from the server. You know, diffing, you're fine. It's when you're trying to do immutable type operations here, where you're trying to keep references and stuff like that, where things kind of start turning into a mess. And in fact, the worst case is the worst. Now, this led me on a search to see, is there a way that I could identify, you know, instead of cloning everything, So we bring that internally, basically do the diff, and then only clone things that would get written. So when you first create the store, you clone everything. But then every time you do a write, you like replace these 3 nodes. Instead of using the immutable reference or using these, you clone just this portion of it. And that way we're not cloning everything. We're only cloning what gets swapped. And this seemed like a good solution, except for the diffing problem is definitely there, right? At least here, if you don't change something initially, you can still shortcut based on reference. But if you start cloning everything, you'll always be diffing to the end. It's like Angular, actually, if I'm right. Angular doesn't use immutable diffing; it does mutable diffing. Like that's kind of the approach they do there. And as it turns out, I was doing a bunch of benchmarking, and there's this very cool repo project where created by local void, the creator of EV, where there's a bunch of frameworks, and Solid's actually in here, old version of Solid. And essentially, it just, I forget if I showed this last time. I can show let me see here, it's right here. I can show the source code for it. Oh no, not for the repo. I need uibench Solid, just to give you an idea of Solid uibench, of what the code. This is a very simple example, but essentially there's a table with a for component. There's an animating thing where it's like moving some boxes around. And then there's a deeply nested tree where you go through each item and then each item is recursive. Like a tree node is a tree node that can have either a leaf or another tree node in it. And then essentially there's a switch at the top level. This is old Solid, this example. This is samples on track. But essentially based on which mode you return, which type of thing you're drawing in the UI, and you spam the page on it. And this benchmark goes by so fast that you can't really see it very much, but let me just run it really quick. You can see it, table, tree, anim, it kind of goes through, and it basically does a whole bunch of these diffs. Now, something that I didn't realize until I spent more time looking into this, and it might not be too obvious here, but yes, you start seeing it in some of the benchmarks, is that Solid in some of the benchmarks will be very high scores at the front end, and then afterwards have like, yeah, I'm not actually seeing it here. It might be the order of the tests, but let me actually show you. You can see it a little bit better here. Yeah, pretty fast test time here. And there's all these different things, like a table of this size, sort this, table of this size, sort this. But I started noticing like there was things that made no sense. Like why am I not seeing it here? Yeah, it's not showing it here. Where is it? Insert. Basically what I realized was that the Solid version of this implementation here was actually bugged. That because we were mutating the source of the benchmark between runs, in some cases it was working to our advantage, in other cases it was working to our disadvantage. We were basically doing a different set of operations than the benchmark intended, because we would mutate the input state essentially, and then like if it fed back the same input state or like something closer, we would actually get like better results. And stuff like reverse was actually very impacted by this, because we'd reverse. Yeah, there were ones that were like positive and ones were negative. So in the end, it kind of was a wash. But the Solid implementation, this was actually wrong, even though the tests wouldn't indicate as much. So benchmark aside, this actually though was a really good test bed, because we could look at something like Inferno, one of the fastest virtual DOM libraries, and look at how it basically renders and how the performance goes. Now, Inferno is faster than Solid on this, but one thing that was interesting was that when you added paint in, like and when you basically did shortcut reference checking, like where you check if the things are the same, the difference almost, and the difference between these two almost disappears in the different modes. Now, that's not too important, especially because I realize that the solid implementation is broken, but I had a test bed that I could use to actually test the performance of the impact of these things. Now, these two are going to be slower because they're measuring the total render time, but if I remember correctly, you're going to see very similar results between these two. My memory could be a little bit wrong on this one, but essentially, they're much closer in performance here, almost interchangeable. And what I'm getting at is I use this as a kind of source of reference to check. I actually made a clone version of the stores. I was like, okay, let's try doing these things. And this was non-starter. It was like way slower than even React, right? If you're slower than React, you know you're doing something wrong. But even the version where I was trying to just clone certain portions of it would just absolutely destroy any kind of creation benchmarks. So yeah, it's a benchmark consideration perhaps, but you start going, this is less than ideal. It's very optimal in a certain set of cases, but then it becomes really like the performance just drops off a cliff afterwards. And in fact, some changes we made around 1.0 made, like, I actually took the current version of Solid in here and tested it, and it scored similar to React, just like slightly slower. And I was like, that's what we've been running the whole time 1.0. I went back to when I made the change, and it was like the release before 1.0. So it was an interesting journey to realize that our diffing performance was fine. No one had complained about it, but it was actually a bit slower than React, which is I'm using as like the baseline here. And it had this characteristic I was telling you about, right? In terms of like the mutability, which could be considered a negative. And once you try and fix that characteristic, as if it's a thing to fix, then this is just not a good solution. So I was kind of stuck. And that doesn't sound good, but the exciting part is I actually solved this. So that's what I'm excited to tell you about. I just needed to get this basis because I spent a bunch of time. That's what I've been doing the last 3 weeks. And I actually got a fixed version of Solid with all the features I want that scores slightly better than this old version that was broken, cheating. So yes, it doesn't match Inferno, but I think I've solved all the other weird characteristics. So I want to talk about this. Reference swapping stores. So I realized, and it was kind of a weird test, that if I added one layer of abstraction between a store's value and the proxy, and I ensured that the signals in the proxy always stored the wrapped or proxy values, I could reconcile without mutation. Doesn't match Inferno, it's a no for me. It's still way faster than React. You understand what this use case is. This is the dbmon use case. To be fair, in dbmon specifically itself, and sorry, I shouldn't have said that right. It doesn't match Inferno in terms of raw iteration time, but it matches Inferno in terms of total render time. So that's why like the dbmon tests, Solid and Inferno, are basically identical, because like the way we render is slightly like it's like the raw diffing is slightly slower because of just invented double pointers in JavaScript. New value, old reference. It was weird. You'd think this would be slower because you would be creating an extra object per node, right? Because instead of just having a proxy where you have an object and then the proxy trap around it, I was suggesting creating an object that has the value of that object on it, and the so proxy trap, intermediate object, value. But some benefit is you don't have to ever clone the original object, and you keep the intermediate object. It's only a cost at initial creation. And something that I didn't realize, which is kind of cool, is the intermediate object is monomorphic. So the proxy trap always gets an object of exactly the same shape, which actually improved the performance. I didn't realize this when I was working on it, but it was like, it had this positive thing. So, but how did I get there? It was a little bit tricky because at first I tried to like swap the prototype, and as you guys can all imagine, swapping prototypes is not a good thing. I wanted to do that because I thought I could save creating extra objects, but it wasn't faster. Funnily enough, making this separate object ended up being faster. So, I mean, the gist of this, and I'll kind of drop it down here, is what if instead of doing all the stuff we talked about, you know, what if we kind of do both still? What I mean is, keep this relationship where if you mutate something, you mutate something, right? That's fine. If you've noticed the work that Dev, and he pointed it out, and it's kind of smart in the stream, he was talking about how create projection, all these things didn't have writing on the outside. They only had like writing on the inside, and we have this kind of flow where things are more derived. If you're not actually, quite often, you know, getting data from server, some external source, a cache source, you're not actually mutating the data always. Yes, if you in the mutate case, this still holds up. But what I was suggesting is, instead of doing this, screw this. Instead, if someone does this immutable and sends this in to reconcile, instead of mutating this, you swap this. So this object is now this object, and then you iterate over only the properties that have signals on them. So only the things that are being listened to. If you remembered in the previous stream, when I did create projection, I was talking about the JS framework benchmark, and I had to release signals that weren't being listened to. Otherwise, the selector got huge. Now that we do that, we're in this interesting zone where stores only have signals for things that are currently being listened to, which means that if you diff, we can ignore, like if we swap an object and you listen along a path in stores, right? So if there's no property over here, it's like no one's listening to this part of the graph, well, we don't have to, like, sure, nothing changed obviously, but even if it had changed, we don't actually have to diff it, because when you switch this object with this object, it's going to have a link to the new object. Like, it's going to be there. So as long as there's no signal there that you have to update with the new update here, you can just replace the whole part of the tree that isn't listened to. And there's no consequence. If it is listened to, then yes, you have to walk through and do the diff on that. But now you don't have to write to every single property during a mutation. You actually only care about what's listened to, which means that what you can do is you can just, as I say, swap this, go, okay, swap. And then you go, let's pretend this is the only side of the tree that's being listened to, this whole side. Then it goes, okay, I'm going to access this property. This is the only one I'm going to. Then it's going to compare this and go, okay, if they're the same key, the same reference, so either the keys match or there's no keys, it's going to swap it again and then check the specific things. And, you know, maybe these are both listened to. So it goes here and goes, okay, nothing's changed. Same reference, skip. And then goes here and sees a change and applies it. But my point is, if you do it this way, the next time another immutable change comes in, now this object is this object. So you can keep on shortcutting, essentially. Like, you don't have to worry. It's actually the immutable change. And because we keep the wrapped values in the signals, we basically don't care that the objects underneath swap out, so to speak. Is there increased memory cost? You would think so, because I'm creating one extra object per store node. But as I said, it doesn't have any negative effect, at least on the benchmark in terms of performance. It's possible that could add up the one extra object. But on the other hand, you're also not cloning stuff nearly as often. So yes, I would imagine that it would have a memory overhead, but you're doing less memory creating and releasing operations. Because like literally you're just like when the old object is gone, when you swap it out and no one else references, then it gets released. Like, so yeah, I don't know. I don't think it has, yeah. And you're doing less work overall. So like, yes, we're still doing fine-grained mutation. So if someone mutates this, yeah, your previous is going to get messed up. But if you're doing quite often, a lot of store work is just reconciling server data, reconciling stuff. This works both for server data and for immutable data like Redux, and it's faster because it like one of the problems is like you start going, I don't know what's changed. So you, like when you mutate, you have nothing to diff against, so you end up just overwriting every property, right? That's the problem with mutation based. Where in this version, like I remember looking at it in the, you can see it actually in SolidJS's reconcile function. It's actually kind of funny. There's a part of the code where if you go packages and solid source, sorry, not source, store source modifiers. In here, there's a part at the end where we're merging objects, right? And where is it? It's an apply state here, where we go and get the target keys and we go and we apply the updated state, and then we find anything that's like not there and remove it. But the funny thing about this is completely dumb. I realized after because if these are the same object, like sometimes they aren't, but sometimes they are, like you get into this weird state where it's like I guess this is fine because technically, you already merged the previous object into the current object, which means that when you do object.keys here, I guess technically speaking, it is important because you get all the keys of the current one plus the keys of the new one coming in. Whereas if I move this statement up here, it would actually be smarter, because then if I do it ahead of time, at least I only need to iterate over the keys that were already there and not the new ones that were just added. So this already is like a micro optimization if I move this up here. But more of it's like, it kind of shows the point of both of these for loops being weird, because like it doesn't know, like all we can do is check if it's undefined. Like it might iterate over keys that are in both objects because it can't tell what's changed, because it's like it is the same object. After you transform it into the same object, there's no previous state to look at. And this is like the kind of constant problem with this kind of diffing thing, where with the new approach, let's see, SolidJS.com, GitHub, SolidJS signals, source, store, reconcile. Where is it? This is values and this is Haskell. Yeah, there's a bit more code here, but what it literally does is it only needs to iterate over it once, because it gets the keys and then it looks at the previous and next value. And because it knows that it's swapping it, like these are independent references, you can literally diff against it and do the update. It's funny. The swap actually happens up here, I think, where it's literally previous proxy is null, remove the old proxy, target, this is like the object in the middle, store value equals the next value. So it's just swapping the value when you get past. This is like the shortcut was like, no, these should be swapped or whatever, like don't merge. But then once you get into the merging logic, the first line is just literally like swap it. Anyway. So you get the properties of immutable internals for diffing type situations. So like multiple, like don't get me wrong, you can mutate in the middle, so you keep this aspect. But if you do multiple immutable diffs like consecutively, you will have the same qualities where you don't have to clone extra objects. And the only cloning happening is the cloning that you are doing as the person generating the data to go in the store. And let's face it, you would clone anyways, because if you just mutated your source data coming in, then it would be the same as the data inside. So diffing wouldn't do anything, right? If it's the same reference and you mutate it, then you can't diff it. So like people who are doing either the data is fresh from the server, or if you're doing like a Redux thing, you have to use immutable sources. There's only 3 ways you can update stuff. All new, rely on the keys. Referential, which means you have to clone the part that changed. Or granular, where you mutate exactly the thing that you want changed. There's no other option. And if you look at it, the solution actually nicely handles all 3 scenarios. So yeah, and it's fast. So like that was sort of the thinking here, coming in terms of the fundamentals, right? I talked about the thing I showed on stream where like there is some rules and takeaways here and caveats. I said this is all good, but there is some problems that I want to talk about and see what the community thinks about this, and that's why I'm bringing this up. One of the problems is that you need keys. Like merge isn't an option anymore because you always merge. If you have a list that has an array of A and selected item A, and then you send this array without knowing keys, you're going to think item A is item B, which means, and this is not new to the swap method. Literally, that's a problem with stores today. If you try and do something like this, it will try to merge these items if they doesn't realize they don't have a different identity. It's going to try and merge them, which means because they share the reference with the proxy and stuff, what will happen is item A will transform into item B, which will mean selected will become item B. When it does that part, then when it gets to here, it will create a new item A. And then when it gets to here and sees that these are not the same, it's, in the past, like it would end up turning them all into item A again, I think. And now, because we delete the proxy off the old one, it will treat it as a new object. And I think you'll end up with maybe the right thing, but you'll have recreated all the proxies for item A, the existing item, where what you really would have preferred to happen would be to retain the proxies for item A, because here you've already rendered the UI with this. You wouldn't want to re-render all the UI for item A. So even the best case I can do here without keys would be re-render everything, but it be correct. You need keys, okay? This is just the thing, okay? Are you just trolling today, Benton? Okay. The other consideration here is you can't change the identity of something. If we're not going, well, this is kind of an interesting thing. Like if you have 2 different IDs and you try and reconcile them today with solid stores, it would transform. You know what I mean? It would basically transform this user into this user. And if this was referenced in like 10 different places, like you'd have something weird going on, right? Because suddenly all the places user 1 is. It's this problem. Like I think the IDs actually prevent us, but like I've never made this clear. I'm going to make this error. You can't reconcile one object into another object with different keys because they're different things. These have to be swapped. You don't want to change all the 1s into 2s. You want to swap them. But where this becomes a problem is that you almost have to nest it now, because if you have like create async and it returns 1 user object, right? And then you want to like on the prop change have a second user object. You don't actually want to reconcile. You want to swap the user if the user changes. You want to reconcile if the same user is the same user, but its data is updated. So it's hard because top level, there's no there's nothing to swap because you can't listen to swapping the top level, right? We do that with arrays because we do a special track, ability, but no one's tracking the top level. You can't just pass store into, like an object and have it track properly. No one just listens to store. You listen to store dot something. So, like, yes, if you did the swap and effectively only the user, like a ID, like if a property on it changed and you were listening to that property, then it would update properly. But it is very difficult. I mean, maybe that's fine, but I think you kind of see where the problem is. Like, we literally can't notify a top level swap, right? So if you're like writing to your store and you want the whole store has an ID, then you know what I mean? Like it doesn't make sense. You can't reconcile something into another. So I think this is probably the biggest thing because, like, as I said, the problem is you just went like this: fetch user, create async, create projection, reconcile user s. It would error or not work as you expect if user ID changed, right? So I wrote a bunch of complicated code. This is like checking if the user ID is changed and then reconcile. But this is actually changing the user ID. Like this is like cheating. This is like saying, hey, I'm going to change the user IDs to its new ID. Now they're the same. Now I can do it. I mean, at least I'm forcing it to be explicit. But the better solution is actually, and this is a trick we use actually in create async store inside a solid router, is put it on a property, and that way it can be swapped, right? This is a consideration people probably have not thought of. So it's something that I'm still trying to get around. I also tried to come up with some other fancy way of doing it. This is like nesting a store inside it's funny that you can do this multiple ways. I think this is still the best way of doing it. Basically putting it on a property. I don't think it's going to necessarily impact a lot of people, but it's just something you got to kind of understand. createSyncStore could do this internally, like we do .value inside createSyncStore. You don't want to try and merge distinctly unique things into each other. You need to be able to swap them. Yes, normalized stores, right? The old Redux thing, right, where you put them on an ID and then iterate over the keys. Yeah. That's probably the best way of doing it, from like a data normalization. If your store is big enough, you're probably going to have to do that because you have relational models. But like the basic case, yeah, I mean, I came up with a few takeaways here to wrap up this topic. If something has an identity, it needs to have a key. If it can appear in multiple places or has other different things of the same type, then it needs to have a way to indicate its unique identity. Okay, so that's number one. I think that's rule one. 2, stores mutate. The performance benefit comes from doing granular updates. If someone mutates something, it is mutated. Okay, pretty straightforward. Reconcile is not a mutation operation. It resets the store to the suggested references. That way, the next time you reconcile, it can do it so again and always be able to referentially tell what changes. I was kind of joking around and calling it like rebase instead of reconcile. It's not quite the right term, but you kind of that's kind of its purpose. 4, you can't reconcile two objects that have different identity. You can't reconcile one identity into another. That's basically my rules and takeaways. I think with those rules, this is consistent. To be fair, I understand this a lot. It's funny because I feel like if people watch my stream, they probably are like get scared away from SolidJS unless they're in deep as me. Because the truth of the matter is, this isn't a how to use SolidJS stream. This is how to write SolidJS stream. The funny thing is, I go through all this pain and all these details and all this stuff so that at the end of the line, someone can just put create signal in a component and call createEffect to update it. I mean, that's sort of the reality of it. I'm not suggesting that anyone go out and do that, but that is kind of how that's where things go. It's just important to create tools in the right way, and then hopefully guide people in that direction. So I'm sorry if this is a lot, but I'm hope the explanation of the capability is pretty clear here. And I actually have a demo for this. I don't think my notes synced. No, my notes are not synced. Give me 2 seconds. I need to grab this demo. Where is it? Solid. Was it on? God, it's been so long since I've been working on this stuff that I sometimes I have no clue how I actually found it earlier. Let me see if I can send it to myself. 2 seconds. I have it on my other computer. It's just my stuff didn't sync. Discord. Sorry about that. 1 sec. Just going to use a public Discord as my sync mechanism. There we go. Cool. Okay, so yeah, I'm very flattered by this whole Ryan script thing. I was trying to write reactive script, but you know. Okay, check this out. So this example looks complicated because it's using the new solid reactivity, but but without the compiler. So I hand compiled everything, which surprisingly is an exercise that I'm enjoying doing a lot these days, just for fun, where I'm just like creating stuff. But what I did was I took one of the oldest examples off the solid tutorial where, and I think actually I had an old code sandbox, and essentially there's this one file that has all the Redux information. This is literally Redux. And it creates a Redux store that has 2 actions: add to do, toggle to do, right? So you can go, you can add a to do, and then you can toggle it back and forth, okay? Now, before I had this custom logic, because I had to make my own undo library because Solid mutates state and I had to make snapshots. But for this test, I literally just took the off-the-shelf Redux undo tool. It was linked off their website. So I was like, okay, I will just use that. And I just wrap it going undoable to-dos and then undo type, undo, redo type thing. So I just tell them what the types are and I passed it in. Because I'd already written this based on this, it wasn't too hard to add the new actions. And then I had to write some logic to map between the structures. But basically I made this simple hook, which creates a store, a solid store, subscribes to our Redux store, and this calls literally reconcile on it. That's all it does. Reconcile, map the state, and on cleanup unsubscribe. So, and there's also this capability to map actions, right? So the way this gets used here is I'm creating this Redux store, and it's essentially you pass in the Redux store, which is actually the Redux store that I created, and I pass in a way to map the state coming in Redux store, which now, because it's undo, has like present, past, and future in it. And it gave me a couple things like to-dos, which is present to-dos. Can undo and can redo is based on past length. I literally copied this example like straight off the Redux website, essentially, and then I passed those actions in. So basically, other than this simple wrapper, which says on Redux store, call reconcile, unsubscribe, and then like writing a simple mechanism for doing mapping, essentially, like you pass a map state and map actions more or less, which is pretty standard in Redux if you've ever used it. This is like, there's no specific code to this problem of undoing here. This is just standard Redux wrappers. And this is a specific store that just happens to use some immutable library from the Redux ecosystem, no special consideration. I was able to, yeah, there's a lot of document create element here, create a UI by hand, which is little bit of fun. I just created a bunch of elements, created some render effects to disable buttons, then appended them all to the page. I did something very simple for making the list, which is not efficient. Every time the to-dos change, I just replace all the DOM elements. Don't get me wrong. Technically, they're the same references. I'm not recreating all the new to-dos, but they are getting removed and added again. So they will paint flicker. This is not Solid's reconciler. This is literally a one-liner. Just to like, this is the simplest way an insert works. Everything else is just returning DOM nodes, doing map. See map array. This is for component, essentially. Basically just hand compiled it. But the result is that we have full, we have full time travel because we don't mutate the state anymore, and we didn't have to do anything special. Basically, all of Redux's capabilities natively just work here without us having to do anything special. So that's the outcome of it. It was literally just a reconcile wrapper. So this is kind of both very fast in the benchmarks and very simple to create a wrapper. This will be very important. It'll make stuff like xstate easier, managing stuff like that. I was very upset with how, like, don't get me wrong. I feel like a lot of these third-party libraries could be set up in such a way that they could do fine-grained updates instead of immutable, and they would be much more performant for us. But this approach to diffing, like right now, Xstate uses like a different store. Someone like I made something called createImmutable once, which is like, this removes the need. I think this new store API between using produce as the default, so like you just write to it like immutables, and using reconcile immutability basically removes the need for having 3 store primitives in Solid or all these different ones. We literally just need store and we're good to go. And then that stores can also be used through projections. So like essentially all the different combinatorics are handled by a single solution. So yeah, interesting topic, or at least from my mind, but I spent a whole bunch of time fixing stores, and this is the result of it. So yeah, I don't know. You can check out this example. Okay. The other thing that I've been working on is I might save this "Are these lakes real?" to a different time. Tanner was trying to come up with a different way to do server components that didn't use server and use client, and I had a new revelation on how to do that. But let's look at hierarchical reactive scheduling boundaries. This is probably more interesting to people who are really deep into the reactivity. So I might just skip the explanation here and go straight to the demo because it's probably more interesting to more people. But the gist of it is, I started thinking really high level that there is a scheduler behind signal reactivity. As much as we, talk about, there is a pull. There's a definite pull there, but there are a lot of things that need to get scheduled to make that pull possible, and they happen in phases. And I really roughly, I said there's 5 phases. There's pure scheduled computations, things like create async, things that you like need to schedule even though they're not like effects, so to speak. Projections fall in this category until we can actually find a way to pull them properly. Then there's pure side of the effects, like the front half, like the render effects and the user effects. It's, if you saw in this example here, you can actually see it in action. I'm actually doing this where there's the tracking part and then there's the effectful part. So tracking part can store undo, and then the effect is do this. This is an example of this kind of split effect approach where you track the reactive state and then you do the side effect. So if we go back to here, the pure side of render effects and user effects would run next. Then, pulling out all the reactive values. Then you do the effectful part of the render effects before doing the user effects, because the users wants to be able to read from the DOM, that's been updated. So generally there's this kind of flow. And I suspect the order of 2 and 3 don't matter because they're pure. Do you know what I mean? Like they don't do side effects. Like you want to render before you do the user effects, but the pure side doesn't really matter. In fact, all 3 of these probably could be combined into a single queue, which is what I'm going to do for this thing. But essentially there's pure stuff, render, user, which is the way Solid works today. As much as I tried to like delete it, we still have the same phases. I got right back to the same place when I tried to solve the same problems. But so all pure stuff, effectful stuff, French stuff. But I started thinking, we have an interesting problem because we don't necessarily always want to run all 3 of these all the time. Like a perfect example is if you're suspending, you'll run all the pure stuff, find out something async, and then be like, nope, not running any of the effects until the effectful parts until till the pure stuff runs. Which is why there's this split, because if this was async, you don't want to run this. And it's not just that you don't want to run this. Quite likely you don't want to run, you might not want to show any of this because it could be torn. Like you could be showing some UI missing, some parts there, classes missing, whatever. So what you want to do is you want to go, no, I know that this is waiting somewhere. I'm going to show a suspense boundary. And then when it's done, I'm going to go through and run all the effects and actually do the actual rendering. But because you do all the tracking here, you will capture all the async on the front half. So what I'm getting at is that like there's different patterns here about when you want to run stuff. You could also do something like off screen where you're like, hey, I actually don't want to run any of this when it's off screen. I don't want to do any work. And then when it's connected, I want it to do work. So I can like hold some nodes in stasis and then bring them back and not have like a bunch of like work chugging along that no one's going to benefit from. You could update the signal like 15 times when it's off screen. You don't need to do it 15 times at the end. You just need it to come in. So, but the problem is you still want when stuff, even if you subdivide stuff hierarchically into these boundaries, like you have like top level app and then you have some suspense, some off screen, these pieces, you still want all the pure for all the parts to run first, this for all the parts and all this. You don't want to run these as individual apps. You actually want to synchronize the pure part, the render part, and the user part to happen at the same time when you're doing a flush. So I started thinking of creating like a hierarchical queue, which could add into each of those 3 queues, essentially, and have the ability to run a specific queue, and then ability to add child and remove child queues from them. And the expectation is that when you run a specific queue, you run yourself and you tell your children to call their run function. Now, the children themselves could, do whatever they want. This is an interface. The children could be like, I'm not running. But conceptually, you can kind of bring everything together so the parent controls the flow down when you flush, but the child basically can halt it or do whatever it wants all the way down. I mean, I talked about off screen. Another one would be like, picture you have a part of the page that people don't really interact with, or like maybe it's far of the screen and you're like, I'm going to update it every 15 seconds. Like I don't need it like freaking real time, because of the laziness and because of the scheduling, we have the ability to control these kind of things. So, yeah, I mean, I go in a bit here and I should probably share this one. Did I already share this one? Yeah, I did already share this one. And talk about like some of the consequences with async and transactions. I'm not too actually worried about that. I think that clearly when people are opting into these different queues, this is a very low level API. I'm using this to build suspense, to build off screen. I don't expect the average developer to be building their own suspense component from scratch, or off-screen component from scratch, or delayed component from scratch. But I'm approaching this from a primitive standpoint, basically making the core of the reactive system have the ability to create any sort of signals-based framework, right? Like that's the conception here. I want to understand what the building blocks are, and this is kind of where I got to, right? You have to consider there's interesting hierarchical considerations. You have to think about that like the impact of if something is not present, then it's not participating, say, in suspense. But I think the hierarchy mostly just works. So I'm going to show another example here of me doing the same kind of thing I've been doing the last little bit, which is what I ended up doing was I made another one of my hand-programmed apps. And what this app does is it creates a signal and a button with an increment, and then a toggle for switching a mode in this custom queue I made, which extends the base queue, which you can just assume does the normal operation, with two methods. One, the toggle between it being this mode being enabled, turned on and off, and then another one that when it's enabled, call the run function. Otherwise, if it's like not enabled, don't call the run function. So this is just disabling basically the whole queue if it's not enabled. And then what I did was I put one counter top level, and then I put the other counter inside this boundary where I passed in the custom queue, which gets toggled. And then simply whenever I toggle it, I switch the text on the toggle. So essentially the base behavior is as I click, the count goes up because everything updates. Now, if I toggle off the boundary, when I click, now only the first one updates. When I toggle it back on, the other one doesn't run all the missing stuff. It just basically just updates again to the latest, because it knows that the thing that depends on it has updated, essentially. So then it runs it, sees that it's updated, runs it once, gets the latest value, and then if it was queued more or whatever, it just goes, okay, I'm already updated, I don't need to run anymore. So update off, toggle on. This is basically the off-screen component if you think about it. See, now it's off-screen, don't care about it, bring it back on screen, and so on. No, this is about the reactivity. The fact that the DOM is there is, it's off-screen is this thing that Vue has, or keep alive maybe. I forget it. They talked about it in React too. I don't think they've implemented it yet. But this idea that you can like hold part of the page like outside of the DOM, because like think about it, in Solid, when you create a component, you just get some DOM elements. If you don't insert them and just leave them out somewhere, like they're still alive, and then you can attach them again. Like you can just like add and like, because all you're inserting in Solid, it's very obvious when I'm doing this document create element stuff, is we're literally just inserting DOM elements. So whether they're connected to the DOM or not is irrelevant from Solid's. Whether they're even DOM elements is irrelevant from Solid's perspective. The whole trick to off screen though is like, you can do this today. You can just stash a node and then insert it and uninsert it. Like you have a tab thing and you have 3 tabs. You can be like, instead of just purely using show, you could basically be like, oh, I'm going to render all of these and then just choose which one I insert, for example. Or you can cache it the first time you insert it. Like there's lots of tricks to do this. But the problem with Solid today is if you create 3 tabs and you have a signal that's listened to in all those tabs, this happens, right? Like you update the signal and those pages, even though they're not on the page, they're updating, they're re-rendering their DOM and stuff. Maybe that's fine. But you're actually doing all the work for stuff that you will never see. Whereas what I'm suggesting with off-screen, and I'm showing it here so you can visibly see it, is when you detach it from the DOM and it's in an off-screen situation, you can freeze it. So updates aren't running, but it knows it's updated so that when you attach it again, it's updated. So that's kind of like what the off-screen mechanism is. I don't. It's essentially a way of holding the queue, so to speak, so that you don't have to do unnecessary work. So yeah, Vue has this, and they might be the only one, but I keep on getting requests for this, and I was like, I started thinking that this was like very similar because this shortcuts everything. But if you like, suspense would just shortcut the actual like effectful parts and run the pure stuff over and over again until async is complete, and then it can then run the effects and update the rendering. So like it's all kind of the same thing. Suspense would be just a different type of queue mode switch based on some other criteria. And the thing is, this stuff can work hierarchically, right? Why not? So I actually made a nested example. Same thing, I just changed the text around. I don't know why I didn't make it an H1. Probably to make it less confusing on the layout, but it doesn't feel less confusing. Let's make this an H1 again. Yeah, I don't know if this makes it... This probably doesn't make it less confusing. Basically what I did was increment first counter, then inside the boundary, I wrote a button and another counter, and inside this boundary, there's another boundary with the counter. So if you want to see it here, I called it off screen. I just ended up pulling this button component. It's like the toggle plus wrap around its children, boundary around its children as this off screen. It's like a pseudo off screen because it actually doesn't remove it. It just, you need to see it in the DOM to actually understand that it doesn't do any work. It just has a button here, but essentially what you can see is counter, off screen, get children. And then here there's a counter and another off screen, which gets children, which has another counter. So you've seen there's nesting off screens, and there's counter in each of them. So if I start incrementing, all three update, right, as expected. And then if I turn off the bottom one, only the top two update because it's the most nested. If I turn off this one, then only these ones update, and so on. If I turn this one back on, it doesn't matter because it's still under this one that's off. And then when I turn this one on, they jump up to 31. So yeah, you can kind of see it up. If I turn this one off first, now only this one's updating. If I turn this one off, increment some more, then I turn this one jumps, turn this one jumps, toggle off both of them. Oh, this one's off, this one's still on, but because it's under this one, it's still off. And then jump. You get the idea. So yeah, like conceptually, like nesting works. Right. This is probably more interesting to me than other people, but it's just this idea that we can generalize the controlling of flushing using the ownership graph. Like it's not just about disposal, it's also about scheduling. And this, as I said, it doesn't help with transactions necessarily. It actually makes transactions a little bit more complicated. But what it does do is help with things like off-screen suspense boundaries, weird place that updates based on polling, you know, like, yeah, it's just, I guess it has supposedly niche appeal, but it is powerful because it handles this whole category of thing. Obviously, someone could try and write this manually. In a sense, that's how Solid works today. But I think it's nice to be able to generalize it. Okay, cool. Yeah, that's all there is to this one. What it means, though, if you've been following along, is we've almost solved all those 2.0 design space stuff. I've been working on like the different primitives I want to see, and I've been writing up like proposals so people can understand the impact of those. And we're getting to a point that I almost now implemented every feature. I need the suspense will be next. Now that I have this, I should be able to get suspense, and I think that's core. Off screen is not so core because like we could put this actually in Solid, not in the reactivity library. Suspense, because the way it reads into the effect queue, probably needs to be part of the reactivity core. But what I'm getting at is now that we have this, the only thing that's left is transactions, which is probably going to be my next thing. Technically, create projections are unsafe, so there's probably work to be done there. But things are coming along. Essentially, like this version of reactivity TSX has all the async primitives, has all the stuff. It's the pieces are coming together, so I'm pretty happy on the progress so far. Okay. Okay, give me a second here. Let's see if I have any This Week in JavaScript to talk about. Because I have not been very on top of stuff, I admit. I think the last time I did a stream was so long ago. It was a month ago. According to Twitter. Okay, well, I apparently did talk about some stuff, so like I'm gonna get that ready here in 2 seconds. All right. It's funny navigating both Twitter and it's been a while, and Blue Sky trying to actually get stuff set up. The internals of the queue look like? I mean, if you go to solid signals, you can see it. It's actually not. It is almost like what I said. It's basically how should I put it? It's basically a for loop, you know, for each type, and then yeah, yeah, it looks like most of my stuff is just me being annoyingly facetious. There was a lot of conversations the last month about you know, like Aiden's tool, you know, with the yeah, what the React scan? Yeah, November 7th is when I last did a stream. Yeah, okay, that's good. And then last one is SolidJS. 1 second. Is diffing and reconciliation the same thing? Kind of. I call reconciliation like the whole process. Like there's a point, like when I talk about diffing, I'm talking about just like the front half, like going, has this changed? And when I talk about reconciliating, it's more of, it's either the second half or the whole process. It's when you're talking about actually taking that information of what changed and applying it or making what exists match what your input is. So in a sense, it is diffing, but it's more than just the diff. It's the resolution of said diff so that the new state reflects in like the old state reflects the current state. Like we change it from how it was to how it is. That's reconciling it. Pretend you're the main source of JS news. could you give me a rundown of the hackathon? Yeah, I wasn't as involved in the hackathon. I wasn't super involved last time either, but David and them did a great job running all those projects and all the things. But yeah, we'll definitely talk about the hackathon when we talk about Solid today. So yeah, let me share my screen and let's get started. Yeah, where are we? God, why can't I? Let's get started on This Week in JavaScript. All right. So yeah, it's funny. I did all that and then I ended up being not on the right screen anyways. So yeah, we'll kind of go back a bit between Twitter and Blue Sky as it makes sense. Although most of the conversation I think is still on Twitter, at least on my side of things. At least a month ago it was. Was there a video that goes through some entries and winners? I thought I saw a video about someone going through some of the entries. I don't know. Was it Jay Larkey again? But yeah, the winners, I have the list because we posted them each time as they won on the Solid Twitter feed and Blue Sky feed. But anyways, yeah, let's look at a few of these. Tired of folks seeing this and thinking React. Oh yeah, right. It's kind of funny. There's this whole conversation about how similar frameworks are getting, and you might not be able to see this code that easily. This is Vue code, but it's literally just ref, which is a signal, random pick, and then like Vine tag template, literally a template. What? No one told me about Vue Vine before. This looks so good, right? Because a lot of people who are on the React side, their biggest gripe with Vue or Svelte is the single file components. So this is like literally Vue without the single file components, Vue reactivity, and whatever this Vine is. I don't know if Vine is even actually using Vue internally to do the rendering. I'm not actually that familiar with it, but it basically, so it's now funny React. No, kind of. It's more similar to Solid, yeah. But also interrupts with traditional Vue files and files of Vue components. Okay, yeah. So this does actually use actual Vue under the hood. So that, yeah, this is closer to actually. It's funny, you can have JSX components in Vue as well. So it's kind of interesting because the people who really like single file components and all the kind of like compilation aspect impacting the top part of their code probably see no point in this. But for other people, this is like the complete game changer that like this is a possible mode here. But yeah, what I was getting at here is that the response was like, now Vue's like React. And I have a little bit of a bone to pick on this one, I think, because Vue is like, why do people see this and instantly think React? I guess React has kind of cornered this whole market of function as a component thing, but like my knockout code was like that. It's very odd to me that you have signals library that has function components, and people from Vue and Svelte communities, I've been seeing this, are like, oh, now they're just copying React. And it's like, ironically, it's like the furthest thing from React. With every major, yeah, I don't know why this bugged me so much. It's funny, you look at something a month later and you're just like, why was I so worked up about it? Anyway. Yeah, geez, yeah, I was definitely worked out. Syntax in JS frameworks is overrated. Is anyone actually surprised the same people who complained about Svelte ruins being too much like React, now that they're migrating their apps, are realizing how much cleaner it is? Ruins were never about React. Yeah. Yeah, I think I was getting very annoyed about I was checking out the Vue and Svelte discords. Yeah. They see function components and think React. Yeah, but I mean, as I said, function, returning the view at the bottom of it was React specific. I'll give, because templating languages used to be on the outside. So like when you built components in Knockout, you would return child components. It's so weird because it wasn't view code, it wasn't divs, but like you would return like nesting of, like you'd write your view models essentially. So you'd have like user list component essentially return an array of user components that returned, a user component that had an address component and something else component. Like you were mapping out view models, but they were basically the data side. And then on the other side, you had templates, which would map out the other side. But yeah, it's just so weird to me because like when I saw React, it didn't feel that different to me. I don't know. So it's like, I especially moving from the single file component, like we've had script tag in Svelte for a long time, or Vue or whatever. Like, I don't know. Like the code already looked like this. Yeah, React. Yeah. Yeah, this is my other gripe when I moved to Blue Sky. All my articles are broken. Did I talk about this last stream? I don't think I did because I said here that I was. Oh, the stream's back tomorrow, so maybe I did talk about this last stream. I can't remember if I ended up actually talking about this, but all my articles are kind of broken because I like quoting React core team members like Seb and Dan a lot in them, and now they're like literally blank, like React versus Signals 10 years later. One of my most read articles of all time. I think it has over 100,000 and some odd reads. This is what it looks like now. These are all missing Dan Abramoff quotes. Well, Andrew Clark's still there. The articles, I tried to find them like Wayback Machine. So the article is basically unreadable now. I don't know. I have a lot of articles like this. It's just really good. I mean, it's not completely out, but like these quotes are actually really important to the article. It's actually really frustrating. Anyway, no disrespect to Dan, but I wish he hadn't nuked his account when he left Twitter. The entire documentation for all modern undocumented React features were buried in massive tweet threads that are now gone forever. Yeah. Anyway, so I posted this one on Blue Sky, and someone was like, pulled out some political thing, and I was like, I don't even know. Oh, side note, I guess is it still open? If you haven't done the State of JS survey, oh, it closed on the 10th. I didn't even get to do a live stream to push you guys all to vote for Solid on here. Whatever, it's all good. God, Valibot's still just growing and growing. I haven't talked to him. I don't know if he found a job. All right. Yeah. Voting opened. Our whole hackathon actually finished since the last time I streamed, which is crazy. Yeah, so let's talk about React Scan for a bit. I know this is old news for everyone, but Aiden just started going around tearing at websites here. And it's kind of funny because seeing the React re-renders isn't the whole story. The performance might still be perfectly fine here, but it definitely drew attention to something that's like doesn't happen in other frameworks. Like Aiden had some side-by-sides, I think, at some point showing other stuff. I'm glad he's getting attention for this. He's been trying to come up with performance is a difficult thing because it's like trying to, I don't even know what it's like trying to sell water to, it's like trying to sell meat to a vegetarian. Right? Like, I don't know how else to explain it. Like people who use React, there's a billion other reasons you use React. Like Million, it has a great approach to, with block DOM of like improving like the core rendering aspect. The compiler can prevent the re-render stuff to a decent degree, although Aiden will tell you not in all cases. But it's like people use the compiler because they're told they don't have to think about something, not because they actually care about performance, which is what's probably made this really difficult. Because, I mean, this is a fun Twitter topic because Aiden can just basically rip apart anything that's React, because almost every React site suffers from this. People get to a certain point where they're just like, I give up. It's good enough. But like, it is interesting because I said this doesn't necessarily lead to actual bad performance. These are React component re-renders, not DOM re-renders, to my understanding. So, yeah. Discord is smart. Yeah. Look at this. This is actually, yeah. I love though that this is at least getting attention. People are just aware of this, which I think is good. But it wasn't the point. This is where the disconnect is, I think, for a lot of people. The point isn't about performance. I don't think it was ever about performance. The same reason when people are like, oh, Solid is just faster. If I was just selling you on faster, then like you have the same problem again. It's because if the crap doesn't re-render, that's just something else you just don't have to think about or worry about. If you truly didn't have to worry about re-renders at all, then like, yes, no one would care. But the problem is like people clearly do care about re-renders, which means that this becomes actually a concern. There's a guy I was chatting with on Twitter who was like basically in one sentence was saying like, oh yeah, I use React compiler. It made, my app a lot faster in a lot of ways. And then on the same side, he was like, there's no point to Solid. These kind of optimizations aren't proven to actually make anything faster. And I was like, but if that's the case, why did React write the compiler? And you yourself says the React compiler had visible benefits. So like you can't have it both ways, right? Like either reduced re-renders are an improvement, right? Like there was a quote that I was trying to find. It took me. I was trying to find it and I couldn't find it. I think it was. I was like asking people. It might have started from Dan Abramoff or something at some point, but like, where was it? Yeah, I'm not even seeing it anymore. It was just a weird one. It wasn't about syntax. Yeah, I thought I posted it. It was basically I was trying to remember. Someone basically said that user code was the whole cost on your framework code doesn't matter for performance. User code does, and my argument was that basically, if the framework helps your user code run less, then there's benefit to updating the framework code, right? That's why the React compiler exists, right? I mean, there is this thread with Dan trying to look at performance. I would happily trade update costs for better init costs. I need to cut down on what each of these things do the first time. None of this reactivity signal stuff helps here. It's just about moving calculations to interaction time. And he's right and he's wrong. He's right that purely speaking, signals and reactivity don't help initial render. Where he's not quite right, and the reason that we've been smashing at benchmarks, even on creation, is that because we know that the update path is separated, isolated, then the creation path can be optimized in isolation. One of the challenges with React's like a game engine renderer where it just like re-renders the scene graph every time you get a change, re-render it. And you know that you're going to get, if your game runs at 60 frames per second, your game will always run at 60 frames per second, more or less, because it'll be consistent. Like you do equal amount of work every frame. It's fairly predictable. So like whether there's everything on the screen changes or one thing on the screen changes, you get the same FPS out and you're like consistently where you want to be. But if the difference is on like a signals-based system, obviously, is the updates scale. Like one update can be way faster. You could be like 10,000 FPS for that or whatever. Like obviously your vsync will get in the way of that. But what I'm getting at is like there's no ceiling on how fast the update can be. But like creation might be lower than that 60 FPS because you basically did make that trade. So in a sense, Dan's correct. But because you've already extracted that update code, you can focus purely. And in the case of the DOM, that meant cloning nodes and removing all the iteration work. Like if you've ever seen a hyperscript, like a VDOM renderer, you're always just iterating over properties. Everything's a spread. Even if it's not a spread, it's effectively a spread. There's you have to iterate through, instead of compiling in direct, like this updates this updates this updates this. Like this kind of switch means that we can clone big chunks of the DOM at once instead of creating them one by one and actually optimize for creation. And this is why, until Block DOM, which also optimizes for creation the same way that Solid does, Solid approach was beating both virtual DOM libraries and on both creation and update, because we were able to optimize both in a way that React could optimize neither. So conceptually right, except for it assumes a lot, right? So this is the classic trade-off between update and init, because yes, signals are more expensive than not signals, but so conceptually there is a VDOM solution out there that would be faster at creation than Solid, but React isn't it, right? That's basically it. Surprised if they have over signals. Yeah, no, VDOM continue with garbage code suppressor as well. You can do component grain reactive library without VDOM for something like block DOM, but the amount reactivates per render is huge. Yeah, exactly. Yeah, it was kind of funny for a while there. Solid was, and this approach was leading the way because it was ahead on both sides. Then block DOM came out Million, which took the one creation side. So technically, they're ahead in the benchmark slightly because they are faster on creation than we are, because they don't have the signals overhead. But that's a whole different category of thing than what React's doing. So I guess there's a theoretical versus in practice thing. But again, maybe we'll find more optimizations in the future. Oh yeah, here it is. Does anyone know the source of that nonsense about how framework doesn't matter because most code is user code? I don't see how one negates the other. Framework can optimize running of your user code. This is why signals are great. Would React bother with a compiler otherwise? Yeah, that was the one I was trying to find. Right? Yeah, right. Yeah. Yeah, because it's crazy. Sometimes you like, I got suckered in for the first time in a long time, getting in a Twitter argument over this sentiment, right? It was just like, you know, when you're arguing against someone who you can tell they know that they're wrong, but they're just trying to like egg you on, and you just keep on like trying to explain it, and it's like, no, they understand. They're just a troll. I have a hard time with trolls because I always feel like it's a teaching moment. Anyway, let's continue. Yeah, sorry, it's just funny. There's a whole thread of like React stuff. 10 stack start officially in beta. That's huge. No, there's a difference between people trolling and like stopping right away. I had like a discussion with someone over like several days, it felt like, and you could tell like they basically contradicted their whole argument in the first post. That's the React compiler, and about how it was on me to prove that those kind of optimizations were worthwhile, even though they just said they were worthwhile. Like, yeah. Anyway, but yes, sorry. 10.6 start official beta, which is great. It's got a lot more eyes on Vinci. Vite 6 also came out, which I haven't reposted, which is huge with the environment API. I've been very excited for this coming out. The biggest challenge actually right now is that we actually can't move fast enough. Like we did update the solid plugin, Vite 6 is supported. We did update to Vinci. There were some bugs. I had to roll it back. Another update to Vinci. Hopefully it fixed it, but I'm moving slower this time. But ultimately, during this update cycle is where the slowdown, like, luckily Nitro and Vinci and Vite were very lockstep for this one. But like Vinci's a few steps behind. So it's like, it's taking a bit to kind of move the whole behemoth. But my hope is that this pile gets a lot simpler. We were forced this direction because the stuff didn't exist. With the environment API in Vite, it does exist now. The pieces that we needed to make Solid Start that Nikhil had to hack together, like he was the same guy who hacked together the first RC examples in Vite as well. Now we can do it legitimately. So I'm actually very excited. Tanner is already exploring how he can cut down some of the stuff on the edges. I'm not working on Start these days, but the efforts are continuing. It's going to funnel back into Solid Start. So very excited about seeing. He's got like a team of a few people working on Tan Stack Start. So there's a lot of progress going there. Waiting for the Astro mention. I haven't played with Astro 5 yet, but you're right. Astro 5 was just released. Let's see. You guys got to a point. I think server islands were like the thing that really excited me, and I already did like a bunch of stuff like simplified pre-rendering, better defaults, type-safe environment variables, Vite 6, experimental features. What are experimental features? I like experimental features. Responsive images, SVG. Yeah, you guys have gone so far along that you have everything now that we're just getting to like the icing on the cake. Server islands were huge. I think that's a very interesting. I love the fact that server islands, for the static case, are even easier or better than PPR or RCs or stuff. Like it's perfect. There's a performance consideration when you're highly dynamic, which would make me go towards RCs. But what you've effectively done, which I like when I look at the spectrum, is RSCs are now squished in the middle between server islands, which actually appeal to the vast majority of the people who would care for RSCs, and then like the Start projects, which are very hydration aware, server function, granular, single page apps with server rendering, where there was a time period where kind of Astro was like islands were very far over, and yeah, like RSC's the next zone of range of where I consider them optimal has just squished in, which really calls into the question the value of server components, which I think is a very interesting conversation. And it makes Astro's story finally, as I said, on the stream a few months back, it like Jamstack is back. Like this is what people envisioned, like the modern Jamstack would be. Like this is it. I'm very excited. It's never been simpler to to actually like live out that promise of this like partially dynamic static stuff. It's this, like React had a much harder job coming over this way because they're starting way on the right hand side. This just dominates the left to the point that it's just like I don't even care anymore. It's like I'm gonna use Astro for like all of the sites, all that stuff. And if I'm gonna do dynamic, I'm gonna do solid start. And I really have almost zero care for next. Even tan stack start if I really care to be in React. Like those two options, the only place, yeah, I'm actually really having a hard time figuring where. Yeah, no, it's just this is great. Yeah, as I said, I don't even know all these other features. I don't build fancy content sites, but mechanically, all the pieces are there, which is really exciting. All right. We're going to talk about that in a minute. Yeah, well, let's switch over to Solid and get caught up on that, or bookmarks. Yeah, let's do bookmarks first. We talked about Vine. I was very annoyed today when Google search and see an AI summary claiming that 95% of Vue apps using Vue 2, when in reality Vue 3 usage is now over 2/3 of the total weekly downloads. Check the source. It's from a very poorly written. Sorry, this is so funny. A very poorly written React versus Vue framework comparison content marketing article made by some random agency, no source for the data, and very well might have been AI generated itself. I almost retweeted this one because like the AI inception going on right now is just so crazy. Like I know like 5 years back or so, there was a bunch of articles that you're like, were these created by AI? They're just written so poorly. Maybe not 5 years, like let's say 20, yeah, we're on 21. So like 3 years ago. And now we're getting like better AI content, but it's funny that those garbage articles are fueling into that better AI content. Like AI in a sense is it always out of date because it takes time for popular things to get popular. And then by the time those things get popular, like they won't get popular if attention's diverted away from them. It's like this terrible self-fulfilling prophecy. You know, it like keeps it keeps I don't know. This is, we'll see how this works, but I can understand Evan's frustration. This is kind of funny. It literally got so bad. It's just like, isn't it like, it's so hard when you're in the situation where you're like, just move forward. Like, think about it. This is like do you take the jump question? If someone tells you that no one has moved to Vue 3, then you'll be less incentivized to move to Vue 3, right? Now, even if most people have moved to Vue 3, if you're getting told that, it might still delay it. Like there's this cascading effect of the proper mentality. This is why I started getting really annoyed about the ecosystem argument with Solid. Like, yes, we obviously have less libraries, but I was getting to a point where like I was hearing that argument echo chambered every day, and it was just like, do I have to just like copy this list and paste it in all these threads so people like, because they'll just repeat it like, oh, because they'll do the lament like, oh, I love Solid, but the ecosystem, you know, and it's like, you know what I mean? Like, it's a game, and I think AI is like the ultimate echo chamber, so it's kind of funny. Yeah, I know it's yeah. What he's talking about is that Gemini now highlights, like when you do a Google search, you'll see the Gemini results. Anyway. What else is here? Oh yeah. This is funny. I thought I had a good result thing. He was complaining that this was longer than this. And if you've ever seen SolidJS code, I do a lot of this because I chain off a single const, and actually your minifier will chain off of multiple consts too automatically. So technically, if you have like 5 functions that go const foo equals const foo, it will actually slightly be shorter than 5 of these. So I mean, I don't think anyone should be worrying about it, but it is kind of funny. But then when you get to what do you call it? When you get to gzipping, I actually think that the function keyword repetition actually might swing it back the other way. But I don't know if this is worth talking about either way. I guess the question is it less or more typing? And I think mostly TypeScript is the reason people do this, because they like being able to go like colon type rather than typing the props. Or yeah, anyways. Yeah, I bookmarked this one. I know React 19 is out now, but the RC, we fixed the suspense gate, so very, very cool work they did. It's always interesting when you hear more on the stories about this stuff, because usually it involves like thinking outside the box. You know what I mean? Like clever solutions, like slightly change the expectation. You usually there's constraints that don't let you just fix it. You try and fix it for everyone, but it's not always possible. So there's probably something interesting on how they came to that solution. But I'm not into the internal story. I don't think GitHub issue actually says anything. Pre-warming. I mean, this is the same reason why we eagerly schedule create async calls. So yeah, I mean, it makes a lot of sense. Oh, React 19's out, so that's good. Okay, done. Caught up on bookmarks. Let's talk about Hackathon then for a little bit here. We've had a lot of winners because we did a lot of these challenges that have been very exciting, because it kept things going throughout the whole thing. We got a whole bunch of new components into what do you call it? I think, yeah, this was the first one, right? Into Cobalt, especially. What do we got here? And we got new user guides that are great, like OrJDev, HSalim contribute color area, color slider, color channel, and color swatch for Cobalt. So they won like $1,000 prizes for these contributions. What was another one? Menglin for UI library trends. They contributed combo box to Cobalt. What else did we get? There's been a lot of these. It's like local first competition, which was, what did we get here? HSM library challenge rating group. Got in there twice. Paul Roque, local first challenge. SolidWire. I don't know if you saw this. This was actually kind of cool. But yeah, it was had it all working with suspense and async. Yeah, create async. Yeah, store use, and then basically taps into the sync engine, the local DB. But yeah, as I said, I wasn't very involved with the judging, but it was, or the voting. Right, much of the things, like occasionally got asked on which challenges would be interesting, but I'm just like, look at this README is better than the README I wrote when I first released Solid. Like, people put work in and they created good things, like quality things. I'm pretty stoked on the activity on this stuff. Yeah, and again, I love seeing Cobalt just get more and more components. Just killing it on Cobalt. HSalim got like $3,000, it looks like. Philippe winning animation library. Ooh, this is something that I've been wanting to see. Highly reactive signals library for Solid. Signals-based primitives, render agnostic, 3DS scenes. Very cool. And there's a doc site too. See, people. Yeah, I love this. Like, any render that Solid can control, 3DS. So yeah, custom renders, DOM. Yeah, this is cool. This is the kind of fundamental pieces. I know there's other animation stuff, but just having the choice out there, this is definitely added to my list now. Very, very cool. Um, AI SDK Solid. There was something that I saw that was like looked really, really impressive. I don't know if I reposted because I was worried about being biased from the Solid account, but there's this native script thing with, and I was like, oh crap, I didn't realize this was an entry in the thing. Yeah, here, Solid Desktop. Did you guys see this? I might have shown this last stream, but it was like it looked so cool. Doing native script iOS development with Solid and reactivity. Honestly, yeah, do single sign-on. Attila's been making some great auth videos. Let's see here. Yeah, and then finally, the grand prizes. The best Solid app went to Giphium by CM Griffing, and then this ecosystem tool with the Solid Socket, which we covered today in stream with Dev. It was completely by votes. There was no like judging community. It was completely by votes, and I think David might have written it, but there was some seconds and thirds that were posted on the Discord. Yeah, here they are. Best app, CM Griffing, another streamer that we've rated a couple times, and honor mention Data on a Replate, and then Solid Socket came first, and then Solid Base, and then Solid Desktop that I showed from the team. David has a whole spreadsheet with all the exact numbers. I saw it once, but I don't have them on the top of my head. I think in terms of unique votes, I think there wasn't a super lot. I think there's over 600 and some odd. I think we're was it 700? There was under 1,000 unique GitHub votes. I know that much, but there was a decent pool of people who voted on the projects, and a lot of really good work done. So it's very, very cool to see. Okay. And I jumped too far. Oh, there we are. Yeah. If you didn't see Giphium, it's very cool. It lets you, it does like an interactive diff, so you can like show 2 bits of code. So it's like showing, and then it will animate between it. It'll like try and match words or symbols and animate between the two. I think one of the funniest and coolest uses of this was that Marco, because the reason I love this is because it's very common that I say that typing doesn't matter that much. It's a conceptual idea. And like, the whole like, I almost remade the Svelte meme between React and like the Svelte like let count example here, because if you actually did it with Svelte versus React, it's almost the exact same as this example here. Like, it's like, yeah, you typed some less characters. In fact, in Svelte, there'd be a script tag around this, I believe. But like conceptually, it's the same number of lines. You didn't actually simplify anything conceptually. But again, this is a great showcase of how Marco has the slimmest syntax. There is nothing that lets you write less code than Marco. So if that's important to you, Marco is the framework for you. Anyway, I'm caught up. Yeah, this month in Solid, we're caught up. So that is everything. I am done. You're right. What's dinner today? I'm actually going out for dinner with my wife. My daughter has a dress rehearsal for her ballet, so we're already going to be downtown. So I thought we would just go out while she was doing her dress rehearsal. She's in the Nutcracker. So yeah, no sushi or pizza, I guess. So anyway, Yeah, and today's 13th. I'm probably not going to stream next week. We'll see. So quite likely this will be my last stream till the new year. I've got some time off and whatnot ahead of me. So yeah, no. You all have a great weekend, and until next time, see ya.